containers in a spreadsheet. And that's how you do it, right? This is the sysadmin database of choice, was a Google Doc, and I put what server it was on, what port was open on it, who to contact, and what the app was. And so I was like, hey, if it's down, this is what we do. But when I went on vacation, I gave that spreadsheet to my coworker and say, hey, just watch this, okay? And if someone calls you, match it up here. That's how it works. We're probably used to that. And then I was noticing that basically every week, one of my container hosts running old versions of RHEL kernel would kernel panic about once a week, so I'd have to go in and restart the box or restart Docker, reload the containers. And I was like, this is boring, and I don't want to do this anymore. I wish there was some automated way to do that. This Kubernetes thing came out, and I was kind of terrified, because even early on, it had this like complexity sort of notion behind it. And I'm like, I don't think I want to do that. This complexity is going to be too much. I don't understand all these components. And I definitely don't want to do it if my kernel's panicking every week. And so I found this new operating system called CoreOS with a fancy, shiny, like 4.0 kernel. And we're like, we're going to run it on CoreOS. I was like, okay, how do I automate this setup of CoreOS boxes? And they have cloud in it. And has anyone been running Kubernetes long enough to know the Hypercube? Hypercube was like they took all the components of Kubernetes, the controller manager, the scheduler, the API server, and they put it in a single binary. This huge fat binary that you could just download one thing, and the second argument would be like, hey, Hypercube API server, Hypercube controller manager. And so I would literally, in systemd, curl the bash down the Hypercube, and I would run it in various ways. And that's how I bootstrapped my cluster. And, of course, I was like, it'll take me a couple sprints to figure this out. And I figured out a new operating system and enough to make Kubernetes run. And I had an API server up. And I was just like, okay, well, let me just try it out. I'm going to run a container, nginx. And the command comes back, and it's just empty. And I'm like, well, that didn't work. I'm like, obviously, I'm missing something. This thing is way too complex. I'm never going to figure it out. And I'm like, okay, well, let me go list the containers and see what happened. And sure enough, they were running. And I'm like, well, they're not actually running. There's no way it's running that fast. Let me port forward to it, and it's there. Like, nginx is running. I'm like, okay, let me try scaling it up to 10, because that must have been cached. There must have been something else. Something is wrong here. Kubernetes is too complex. And scale up to 10, and it just works. I was like, I don't know what's going on. But I show my coworker. I'm like, hey, I think I got this Kubernetes thing working. I think we can move off those Docker hosts that I have, and we can start having the web team deploy to this. And what he told me was, that's cool. We can't change everyone's workflow to do that one thing. We can't abandon the 15,000 lines of Perl that we have to provision a box to allow someone to do it this new way. So what you have to do is you have to integrate what you just did into our standard tooling. So it took me 3 months to do that. What I thought was going to be complex with Kubernetes actually was much more simple than backporting everything into our existing frameworks and tools and workflows to make sure that no one had to change anything, and this would just work. But eventually, we got to the point where that was out. Web team could deploy applications automatically in a load balancer, and these hosts were there. And that was my first, 4 months later, my first Kubernetes cluster. And anyone that tells you that cloud native is all about treating your servers like cattle, right? Like that's the thing. It's if you're a vegetarian, you treat them like crops. Okay, it's like not pets, we want cattle, not house plants, we want crops. And like that's the cloud native way. And I'm here to tell you that I literally wrote the book about cloud native infrastructure. I have written the definition for the CNCF of what cloud native is, and I'm telling you that that is not true. You do not have to treat your servers as cattle or disposable to get the benefits of cloud native. The benefits come from a lot of different things, but mostly from changing behavior. And that is the thing you actually want to drive. And when we take Kubernetes and shove it into the old way of doing on-prem, that doesn't give you benefits. One of the main reasons that I see a lot of people moving to the cloud, and I worked at Amazon and EKS for quite a while, is because they want to change the behavior and the process of all of their people. And they say, hey, what if all we had was APIs? What if that was it? What if you cannot SSH? Well, you can still SSH. But what if, like to stand up an infrastructure, you have to call APIs? What if everything was API-based? And that's how we're going to change the behavior. And so my first on-prem Kubernetes cluster was absolutely pets, because I ordered the machines, and I helped unbox them and rack and stack them, and they were pets. They had identities on the network that I cared about and I was responsible for. And these were the 6 machines in my first Kubernetes cluster. And they were pets on multiple levels, because if you know any of these characters, some of them are actually pets. And so that was okay, because I cared about the identity of the machine that I was responsible for. The operating system and the workloads were disposable to me. But someone else cared about the identity of the workloads, right? Like that was their pet. The DNS entry to get to their service is not disposable, right? Because there's DNS cache, and you can't just delete that and move it to a new load balancer, because people were going to fail. So there is all of these layers of the stack. Someone cares about them. Someone is responsible for them. And I'm just saying it's okay. If you're running on-prem Kubernetes and someone's like, you have to make it disposable, I'm saying they're making you do too much work. Figure out what layer you care about, and that's okay to make that your pet or the thing that you're responsible for, and maybe can't go away. Fast forward a few years, I still like on-prem Kubernetes. I like Metal. I like doing this stuff. I have worked building it as an engineer, and I've also worked as a provider of these services to other people. When we were building EKS Anywhere at Amazon, I gotta remember that doesn't work, I built a home lab cluster out of an old Mac G4 Cube. Because I needed a lab, and I was like, hey, I want something that looks cool. I want something that actually is neat, and it was my pet, and it still exists. And to my knowledge, it is the most expensive Rickroll that exists, because my node names are never going to give you up. Because I just like to troll people sometimes. But that's okay. Like this talk is to show you that range of all these things that you can do. I am not going to go in depth on a lot of the tools, because I have very specific things that I have used in production, I have built, I know very specific things, I know about a lot of other things, and I would love to talk to other people that have opinions about some of this stuff too, because that's how we learn things. But first, I do want to talk about why are you running on-prem? Because that is an important question, and that is just something that sometimes it's just inertia, and maybe that's fine. And there's lots of reasons. You can have all of your own reasons. And this is usually the one that is the most important, because you do not make the business decisions about where infrastructure runs. And you were told this is where we're running. And that's fine. That is a valid reason that people run on-prem. It's also maybe because you like it a little more. Like maybe you don't like EKS or something else, and you're just like, hey, actually I want to do this. And that is a valid option, even if it's for your resume. Sometimes this is resume-driven development, but remember, you have a business contract with your employer that pays for your time. So don't go too far down that rabbit hole. There are plenty of other reasons, like needing to understand the components. Maybe you need to tweak certain things and you like bare metal. Maybe you don't like calling your service provider and getting API limits raised every week. Maybe you just like to deal with the physics of it and have that be the problem, right? These are, again, completely valid reasons. Maybe, just maybe, you're just like, I need more tickets. I'm going to gin up some reasons that I need to do this. And maybe you just want to understand the broader scope of the impact of something like this that is like the core infrastructure in your environments. And you're like, hey, I actually want to go talk to the network team a little bit more. So this is my gateway to go talk to them. One that I don't think is always a valid reason, but maybe you're not vegetarian and you don't do CrossFits and you need some other identity. Like you need this component that's like, this is who I am now, and I'm going to tell everyone about this thing. And try not to do that one, but I see it pretty often. Yeah. It can be cheaper, and I hear a lot of complaints right now. People are saying that you're running Kubernetes and you're only using 40% of your CPU, right? If you have a sunk, like if it's a CapEx spend, and the only way you can make that cheaper is to use it more, right? You already spent the money, so the thing you can do is to use more of it. But people are like, oh, Kubernetes is only using 40% of the CPU. I'm like, have you ever bought a server from the last 20 years and had someone run one app on it? Like, that's not using even close to that. Like, we can utilize things more. And sometimes we do that through VMs, and we say, oh, we can pack the VMs tighter with containers, and we keep getting these smaller units of things that we ship. And at some point, they're like, hey, how much is enough? How much is enough utilization? How much is this might be cheaper? And running it on-prem in the long term absolutely can be a cheaper way to go. And so, like I said, this is for a lot of different environments. If you are in a data center, and you are responsible for the data center itself and the infrastructure, you will have things that exist in that environment. This is not we are going to replace everything with Kubernetes. If you are trying to replace everything in your data center with Kubernetes, we should talk, because that is probably not what you think is the actual outcome of it. Like, that eventual goal is not going to happen. There are other reasons that people built the data center, and you're not going to shift everything into it. So you have to work with things that exist. All of those other workloads need to know how to get to the work, this stuff happens, right? We just need load balancers. We need ways to discover these things. And if you say, well, if you just move your stuff into Kubernetes, that is definitely the way to start a political battle at any company. Trust me, I know. Those company politics are one of those things that come up, and my first Kubernetes cluster basically failed for these reasons, because I was very naive about what Kubernetes should be to people and how it should be run, and I did not have any of the, I didn't know the reasons that we ran anything else. It's like, why can't it just be Kubernetes? And basically got shut down. If you are in an edge environment, you will have different constraints, and by edge, we want to get on the same definition here. I define this as something with limited capacity. You run in an environment that isn't, data centers also have limited capacity, but that limit is usually like how much power you can get from the power company, or maybe how much cooling you can do. Edge is limited in other reasons, like maybe your network goes down twice a day, or is on like a 4G connection and isn't fast or has high latencies. This is what I'm meaning by edge environments. Maybe you don't own that closet and someone has hardware access to your boxes. Something you may want to consider if you're running this on an edge, and things like cooling and what kind of boxes you get, those are all important too. If you're running this, anyone have a home lab that they run Kubernetes on? Because that's what we thought. Okay, cool, awesome. Other considerations here for if you're running this at home, you probably have a family. They like to see you, I guarantee you. Whether they complain about your bad jokes or not, they probably want to see you at some point. Just beware. If you have pets, not the server kinds, but the ones that might chew on cables or clog your fans with hair, those are problems that you need to consider. How much electricity you actually want to consume, because if you don't have solar or power is expensive, this is a problem. That Supermicro on eBay probably looks great. If you've ever put one in your house or in your living room, you have other things you should just talk to someone about this first before it shows up at the door. These are valid considerations. If your cluster upgrade stops your kids' Fortnite or YouTube, again, you are going to make enemies in your house, and don't do that. But the one that I always come back to is my kids don't know what a pager is, and when I started talking to them about the on-call rotation for this, they were like, "Get out! Like we are not going down this road, and you need to make sure everyone's on the same page of how much responsibility this is going to be." All of those environments have varying ways you have what you're running Kubernetes on, what the OS is actually provisioned to. And I'm breaking this up into a few options of bare metal. For hardware, you just literally, the kernel is the closest to the hardware as it can be, right? We're not virtualizing it, this is just hardware. And if you are responsible for the hardware piece, you also are probably responsible for these things. And in this case, if you are responsible for those things, I'm also saying that your servers are probably pets. This is something that you care about the identity on the network. If you know a MAC address of any of your machines, you probably care. This is just an easy way to determine if you care or not. If you're virtualizing it, then you say someone else cares about that MAC address, and I care about the virtual MAC address, and then you kind of care about these things. And that is maybe better for you. If you have a VMware team, Tell them good luck on the migrations. If you don't have a VMware team, then you might also be responsible for this piece. And then again at home, like just make sure you know. Hopefully this battery doesn't die. I don't see any batteries in here, but we'll get something. I love using old enterprise hardware. Like, I think that the micro desktops and even old laptops make great Kubernetes nodes. Just FYI, I've been telling people about that for a long time, and even though I have some Raspberry Pis, almost none of them are part of any of my Kubernetes clusters. So now let's jump into, hey, you've decided that you're going to do this. This is something that you're like, actually, no, I'm all in. Like, this sounds great still. Like, I still want to go with it. There are some options for provisioning, which is specifically like the operating system provisioning usually. Some of these will tie into like, hey, we also do the top level bits of, we'll put things on the OS. But in many cases, these are like, hey, we're just going to get the OS on a box. Oh, thanks. Wait, oh, this is actually like, servers, whether that's bare metal, VMs, whatever, you probably need to install a kernel at some level, and these are some options. Again, I'm not going into all of these in depth because all of these are classes on their own and complete talks. I will say that these are all usually tightly coupled with the operating system they are deploying. So don't give yourself more work. If you are a predominantly RHEL shop, do not use Juju. As much as you might like Juju, and yes, you can do it, and you can cross-provision a lot of these things, but the templates and the defaults are going to be much better if you say, hey, I like this OS, so I'm going to go with that operating system and that vendor stack, because that will save you a lot of time. And provisioning CoreOS, or now Flatcar systems with something that wasn't Matchbox was much more difficult. And then at the bottom here, there are some generic options which like aren't tied to an operating system. Again, those are usually going to be a little more work up front. You're going to have to learn a little more things. You're going to have a lot more flexibility, which also equals more work. Okay, so just be aware that whatever you're picking here for your environments, find the one that's going to be easiest for you usually, or the one that already exists. I gotta stop clicking on it there. There are lots and lots of products that will install Kubernetes in your environments. This is some of them. This is not all of them. This is just the few that I know that have been around for a while. We'll talk about a couple of them a little more. Oh, by the way, I'm completely biased in this talk. I just want to say, like, this is not a completely neutral talk. I have done a lot of these different things. I have used KubeSpray. I have set up OpenShift. I help build EKS Anywhere. I now work at Talos on Omni. So like, this is absolutely a biased talk. I am sorry. Again, I love to hear your opinions on things, but just FYI, everyone has some biases. If you are looking at any of these things, you probably know at least the basics of what some of them do. But again, I'm not going to go into all of them. I will save you a little bit of time here and just say that if you are not using one of these stacks on the bottom, if you're not already an AWS or GKE customer, you probably don't want to use their products to like provision on-prem. Just FYI, and I help build one of them. If you have never read any news about Broadcom, you may not want to use Tanzu. Just FYI, just if you are looking at Tanzu, I actually think it was a great product when it was coming out. I thought it was a lot. I have friends that work there. There was a lot of cool things they were doing, but in 2024, and you are getting started, go read some news first. Just save yourself some trouble. And for Anthos, it's like whatever the PM wants to rename it next week. It's GKE Enterprise now, I think, but there's another name for it. So yeah. But again, we'll talk a little bit about them. Nutanix, if you're not already using Nutanix to manage some of your stuff, again, it's probably not, like, you don't want to jump into that ecosystem to say, I just want some Kubernetes mixed in with what the other stuff I have. So the other ones might be a little more of a, hey, I just need a little bit less of an ecosystem, and I just want the Kubernetes pieces. And also for like some of these, like you have to be enterprise level customers of them to even get like sign up for support. So like Rancher and Omni and OpenShift, like you can just go like say, hey, like I don't actually have a RHEL contract, but I would like OpenShift support. That's okay. You can minimize the amount of support you're going to get from them as well is a good option. Almost all of those break down into one of these technologies. KubeADM is, if anyone use KubeADM, is a command line tool that will like start a cluster for you. It is embedded in a lot of other tools. It is, if anyone remembers the KubeUp script, KubeUp.sh was the original bash script that was like 3,000 lines, and it would like stand up a cluster for you in a cloud environment. And we were running this bash, literally curl to bash this thing, and like, hey, I got a cluster, this is amazing. And someone's like, actually, let's make that a little more generic and a little smaller. And KubeADM was kind of the outcome of that. So it was like, hey, we can take any operating system, we can bootstrap your certs, your database, your API server, all that stuff. It has these stages. KubeADM is kind of the way that a lot of people start. If like it's the manual way, it's that. Cloud Init and Ignition is obviously like you're starting up a system that's like, I need some configuration. Tell me how to configure. A lot of people just shove KubeADM in there. That's like, it's kind of one and the same at that point when you say, I want to configure this thing. If you're really good about it, or some of these products will do this well, they'll tend to bundle that up into like a Packer image. So they say, okay, now we take that VM, we KubeADM it, and then we roll it in Packer, and then we can deploy the Packer image. And that's how you're gonna get a fully bootstrapped OS in some environments, and that's OS and Kubernetes. So that's these are just stages of kind of the same thing so far. API-based deployments are kind of missing in a lot of the scope of these things. Of like, I just want, like, this is what a cloud provider would give you if you're running somewhere else. Like, EKS, give me a cluster. I'm not going to do any of these other things. And that's kind of the interface you're going to get. And that's what Cluster API was supposed to be, is kind of like. Cluster API is kind of a unique beast. Because I feel like Kubernetes, we have forgotten how to make an API that was not a CRD. And we have forgotten how to make any API that we can just call that didn't later require 18 controllers and etcd to store the data. And APIs are kind of missing in all of this. And I can tell you right now that all of the cloud providers that give you a maybe good experience, hopefully reasonable experience if you're going in a cloud environment, do not use Cluster API. Because an API that's well-defined to their service is a much better thing than trying to cobble together Cluster API to do everything. And for most of those providers on the last slide, Cluster API is actually just KubeADM via SSH. It's literally, KubeSpray does the same thing, but where the SSH comes from is different. So with KubeSpray, you're going to do it from your laptop, and with Cluster API, almost all of those providers are, we are going to do this on, if it's bare metal, they will say, you give us the IP address and an SSH cert, and we will KubeADM SSH into that box, and we will suck some data out of it. So just so we like fully understand here, because again, EKS Anywhere was built on Cluster API. It seemed like a good idea at the time. This is what you have to do. You have your laptop, and you say, I want a Kubernetes cluster. And the very first step of anything Cluster API related is to run a Kubernetes cluster. And this is a bootstrapping problem, and some people think it as a good thing, and those people are probably language developers that want to compile, you know, Rust with Rust. And they're like, oh, it's really cool once Rust can compile itself. And it's like, it's really cool once Kubernetes can compile itself. And I'm like, no, it's not always the case. And so you have to run Kubernetes that calls some APIs maybe if you're VMware, but most likely a lot of these are, we're going to SSH to a box and run KubeADM, We're going to suck some data off of it. And then, and we're going to put this back in our little Kubernetes, and then we're going to move it over there. And we're going to run all these controllers, and we're going to run all the CRDs into that cluster we just made so it manages itself. I thought this was a good idea at first. No shade to the cluster API folks. They have done some great work. I think it's really cool. I do not want to be running it, and I don't want to be responsible for it, because if you lose access to those things, cluster or controllers are kind of hard to debug sometimes. If you need to upgrade this cluster, you now need to you need to run another Kubernetes cluster, suck the CRDs out of it, run those controllers locally again, go through and upgrade the cluster, and then put it all back. There you go. There's one. And then throw it back. Your laptop is now like production critical, and we have learned lessons not to do that in the past, and in many cases we are doing this again. And so the brightest idea we have for like, well, don't make your laptop part of production, is we say, okay, well, what if we made another Kubernetes cluster? And what if we put the Kubernetes cluster over there, and it was responsible for the other Kubernetes cluster? And then that Kubernetes cluster makes all of the Kubernetes clusters. Cluster API is not for people that have even dozens of clusters. This is for providers that they're like, hey, I want the flexibility to deploy a cluster everywhere. Because they say, hey, I can take out some of the abstractions of what Kubernetes is, and I can put a bunch of specific details in what that Kubernetes cluster is. And you say, hey, if I want to deploy this to 5 different service providers, maybe Cluster API can condense some of that. But in reality, how are you going to upgrade that cluster there in the middle? Like any other upgrade you've ever done to any core service in your life, your DNS, your DHCP, do you want that in a Kubernetes cluster that you have to upgrade likely 3 times a year? Like the last time I upgraded core services was not 3 times a year. So let's talk about the other options briefly. Again, I am not an expert in all of these things, and I have biases. Kubespray is great because it's a neutral product. It is Ansible based, if you've ever used Ansible, which is SSH and kubeadm. And it just says, hey, I run this SSH from my box. Again, you're putting your box in this production workflow, but maybe it's also Jenkins. Who knows? The cool thing is, because it's just kubeadm, there is no operating system like this. It works better with this one. It's like if you get SSH, it's probably going to work. And this is how a lot of people start, and this is fine. You get an OS on something, Kubespray to it, I have a Kubernetes cluster. That was cool. This is not cool when you're like, that cluster is now 50 nodes or 100 nodes, and you're like, actually, SSH is really slow. And it's fine when I'm using it as a person because actually I'm slower than the computer, but when you're trying to automate it and that's running forever and you get all this YAML output, and I'm just like, I don't actually want to look at Ansible playbook runs anymore, please just make someone else do that. If you're getting started and you have small-ish requirements, Kubespray is probably the right option for you. If you have edge locations again with like network connectivity, like SSH isn't great at like, oh, network dropped. Like let's start over. Ansible can do some of that stuff, but again, you're dealing with state on multiple levels of how you SSH'd in, where kubeadm was with it, where Ansible thought the playbook was. There are lots of things to consider here while you're trying to do something like that. How many people are using Rancher? That's one of the most common things that I see in a lot of places, because Rancher has been around for a long time and has a lot of integrations and a lot of features. And it's K3S based, at least I don't know, I used Rancher a long, long time ago, and then I started using RK2 as like testing it and seeing how it worked. I don't know anything that happened in the middle. But it does have a lot of features. A lot of the features with RK2 is, again, it's cluster API based. So it's like, hey, you can deploy Rancher clusters to anywhere. And in this case, that's what the tool's trying to do. And it's saying, hey, I can abstract away some of that stuff. You give me the YAML, and we're going to put this anywhere, right? Because everyone likes writing YAML. Some of the like on-prem provisioning stuff was a little bit lacking last time I tried to deploy this to bare metal. Again, it's like you can do the kubeadm SSH thing. They also have Elemental OS, which is OpenSUSE based, which you kind of build ISOs and then you pixie boot those. I don't have in-depth knowledge on how RKE2 is working. But if you're in that boat and you need a lot of integrations and you want proxy support for like who controls things and RBAC, you should absolutely look at Rancher. K3S based, someone else can tell me this, but like it's a great tool. It is low requirements for a Kubernetes cluster. You don't actually need 5 nodes to run the actual backend, which is usually a problem. And that's awesome because that will probably scale more than most people need. But if you do want high availability and you do need 5 nodes, the story there to get upstream Kubernetes, I don't actually know that piece. I don't know how to make K3S stream across nodes. I know they have backup things for SQLite. That's a question that I don't even have. OpenShift in OKD, as Rancher had lots of features, OpenShift had lots of opinions. And if you are deploying OpenShift, you're going to get everything. You're going to get the CI/CD, you're going to get image streams, you're going to get build packs, you're going to get custom CLI, and Red Hat will tell you all day, every day that it's just Kubernetes. And if you are using OpenShift for just Kubernetes, you don't need OpenShifts, and you are paying way too much money and probably doing too much work. If you're in the RHEL stack, the Red Hat stack of things, I guess the IBM stack, I don't know. It's CoreOS based now. It's a lot of things that get mixed in there. I don't know. If you're in that stack, you probably know what it's like to run Red Hat Enterprise software and how those upgrades work. And every time that I would upgrade our Rev servers, which I think rebranded now, or our directory servers or Foreman, those were big events, and I don't like having pieces of software that have big events to do. But if you are in that space, this is probably the right option because you already have a support contract. And if you have 0 opinions, this is the one to look at. I will talk about EKS Anywhere just because I'm very familiar with it. And to my knowledge, it's the only cluster API-based provisioner that is not SSH with kubeadm. Because with EKS Anywhere, they decided that we wanted to own the full provisioning of a server with bare metal. There is also other providers that are CAPI-based, but it runs Tinkerbell. And Tinkerbell is a generic OS provisioner that came out of Equinix metal, and so they run Tinkerbell. And it's a very interesting tool, and it is a very complex tool. And when you put CAPI on top of it and you run it in Kubernetes, again, I do not think that every tool that you're running in your data center should be running in Kubernetes, especially the core services that are required to spin up Kubernetes. And EKS Anywhere has the same kind of model of admin clusters that create other clusters. Surprisingly, EKS Anywhere doesn't run any of the Amazon Linux distros. Politics. So we originally shipped it with Ubuntu, and then we had to shift people over to build their own Ubuntu, and it does support RHEL now, I think, but it's a long process to get to a cluster, and I was training people on this for over a year, and when I've come to discover when the first step of I want to deploy a Kubernetes cluster and I say give me a MAC address, that's probably the wrong question. It's like you're gonna make a CSV file with MAC addresses is not how you necessarily should. That's not the best practice. It is an old practice. It exists for a while, but when you're doing this inside of Kubernetes, just maybe not. I do now work at a company called Sidera Labs. We make a tool called Omni. The thing I knew about Talos Linux 7 years ago, when I was still building my on-prem Kubernetes. And the interesting thing about it was the fact that the operating system only has an API. There is no SSH. There is no, the thing that we wanted people to do to move, while we moved to a cloud, we say everything's API-based. So that's the thing we want, and we want people to change behavior. It's hard to do when you still give them all the other stuff. And Talos Linux only has an API, and it only works with Kubernetes. So this isn't a generic purpose Kubernetes. This isn't a thing that you're like, oh, we could actually just use this everywhere. It's like, no, you only use this with Kubernetes. There are, I literally, when I started the company, I went through and I counted. There are 12 binaries on the entire operating system. And that's interesting to me, because I could sit down and tell you all of them. And I can tell you what half of them are for formatting disks. That is because it works on bare metal and because it works in environments. Like, hey, actually, we just need to make like a file system, and so like that's how LVM and all these other things work. And so we pull those things in, but like 3 of them are just like, well, here's the API, and you can deploy this, and that's like, oh, that's what I want from AWS. Is I just want the API to do the thing, and Omni like controls all that. The one thing that it's available for home lab use or test environments, but it gives you an API that's not cluster API based. That is just like a standard API. Like I can just call an API and like deploy an operating system and Kubernetes without baking things and without scripting things and without doing all that other stuff, which I really, really enjoyed. The first time I did, I'm literally building Kubernetes or EKS Anywhere, and I try out this thing, and I'm like, wait a minute, this should be harder. It's like all the complications, we're building it into ourselves, is not necessarily the thing that you want for an on-prem environment. And Kubernetes, again, it is complicated, and I am a testament that it can be as complicated as you want it to be and as integrated as you want it to all those other things, but the complications are probably from all the other things you have, and because you're trying to fit that new thing, that the behavior you want to change, into that 15,000 line Perl script. And once you say, like, I need Kubernetes to work with that, then you're probably not going to get some of those benefits. And that's the thing that I think is one of those critical, important things that a lot of people just miss. And they're like, we just want Kubernetes in the way we've always been doing servers. And so that's my opinion on it. I could give a demo. I don't need to give a demo. I don't always like giving demos, and I actually don't even think I have it set up right now. And it'd be hard to do with one hand. So I can answer questions if anyone has questions about on-prem Kubernetes. And again, if you're afterwards, if you want to talk about some of those other options that I talked about and I don't know about, if you have another, like, I think this one's great, please tell me about it. And since my other mic is dead and I have no proctor in the room, I'm going to be running the mic for you.
With the Cluster API you mentioned, you can provide, so I looked at Cluster API in the past. It seemed like, to the points I think you were making earlier, you have to feed in a fair amount of configuration to get it working, where it kind of felt easier using Terraform. And it sounds like there's another option where you could use Cluster API if you just already have nodes set up, and it just uses kubeadm over SSH. Is that correct?
Yeah, most of those providers will SSH a node. You give it IP addresses and SSH key, and it says, okay, I'm going to go SSH to them from a Kubernetes pod. I'm going to spin that up. I'm going to SSH in. I'm going to run kubeadm steps, and then we're going to suck some data back and know the state. And some of them, like Rancher, will install an agent, and it will report back and say, hey, I'm going to keep this state going. Some of them will do it with a workload. It says, I'm going to deploy a daemon set, and we're going to suck that information back. They do it all different ways, but like the initial setup is like, I need SSH to that box. And if you are doing Kubernetes and you're like, I need a full general purpose Linux, then like you might be doing too much work. And systemd, I think, is a fantastic init system, but it also makes a lot of work. Like it just adds a lot of bloat to a system that's like, actually, I need to run the kubelet in containerd. Maybe I don't need everything. And that's one of the really cool things about some of the minimal operating systems. That's like, let's just strip that down a little bit.
So I've seen different things pertaining to Rancher OS and OKD. And so what exactly would be the difference between them? Because I know they both have their monitoring something or other, and they both have their CI/CD something or other. So why would one choose one or the other? What would be the difference?
And I would say if you are on the RHEL stack, choose OpenShift. If you are not, you'll probably want to choose Rancher. Like that's like the main difference. And I mean, they're both like, Rancher is going to be SUSE based, and you're going to be a SUSE customer. The hardest thing most of the time with on-prem environments for me was I had to go talk to a lawyer to like buy support somewhere. And like that's the thing that took the longest a lot of times. It's like I need someone like to be able to support this because it's a production workload, whatever reason. It cannot just be my team that supports this. And whoever you have relationships with usually is the one that I say go with that one to start. And I know a lot of people that OpenShift was a great starting point as people started containerizing things, and they have all the build packs and they have all the stuff that's like, hey, we can move this to OpenShift really quick. And then they find out they don't like some of the opinions. And they say, oh, actually, like I want it to be different. I want to use Jenkins for whatever reason. I want to use something else. And once you have your own opinions OpenShift might confine you a little too much. I still feel like OpenShift is opinions and Rancher is features. And Rancher has a few more that are flexible that you're like, hey, I can use your defaults, but also I have a little more flexibility in how I tie that in. Oh.
So another one, I guess on TalOS in particular, we're getting requirements from some of our customers for FEM. And I know nothing about FEM, but is TalOS or some of these newer methods that use like Flatcar Linux compatible with those methods?
I will generically answer that in that most of those, we have a requirement for some security thing, we need validation on this thing. The more you can push away of like, it's not possible, it takes longer for the rest of whatever spec to catch up with, like, it's not possible. One of the reasons we had a lot of people in AWS use Fargate was like, hey, you just can't do that anymore. You don't have any access to the host, so that problem goes away. And we had a lot of people that are like, hey, I love problems going away. And that's one of the things with something like Talos that has no SSH. That's like, what do you need to do? It's like, oh, we need to make sure SSH is secure. Literally, Talos is not in the AWS Marketplace because AWS Marketplace requires us to verify that our SSH keys are like secure. I'm like, we can't. Like, there's nothing. Like, I can't do anything about it. Like, there's nothing we can do. And so, like, there is this moment of like, hey, this just doesn't, it's not a thing anymore because we've thought about this differently. And it does take time for that stuff to catch up. And so if you have a hard requirement on an industry standard or something that's like you need this certification or you need this other thing, that stuff just takes time for most of the industry to catch up on any sort of, you know, certification. So I don't know the specifics on that requirements, but I do know that like almost all of them, it's just like, it just takes a while for them to understand like, oh, we have to do things different. Every like security vendor, and things in the past that were like, hey, we need to validate this thing. I remember one of our requests early on was like, we had a requirement on Active Directory for all of our servers, even the Linux boxes. And they're like, hey, we need you to run all of your containers and join them to Active Directory. Because that was the spec that said, hey, this is how we validate things, and this is how we have controls over things. And I was like, no, you will not, like like, we will have other problems in this space, even if you're adding these pods into your generic pools of IP addresses, like these are ephemeral, and we don't want them to come up, get IP, go down, and joining, like all that stuff goes out the window. So like there's just a lot that catches up in any of these environments, and as you minimize your responsibility, you have to just have that conversation of like, hey, what are we actually doing here? And in most cases, all the daemons that were like, hey, we need kernel modules. It's like, how are those kernel modules getting there? Like, well, we do it in the bootstrap process. It goes in Packer, or we SSH in. It's like, okay, well, maybe we don't. And you know, eBPF and some things are catching up. There's still a lot that is not there. Most of the tools that don't work with Talos right now are because they exec into the host and they expect binaries to be there. And they're like, hey, where's my bash? I was like, sorry, your tool doesn't work because you literally shell into the host and use bash. I was like, that is just SSH. Like, you just did it the same way.
Thank you. Coming from a non-Kubernetes guy, just learning, I think you kind of touched on maybe cyber security frameworks that these environments need to match up with. Would pretty much a lot of this be figured out in development, kind of seeing what works, what doesn't, and then you have some end goals of maybe aligning what the industry needs or the company needs for frameworks? This would be settled in development before it reach production?
I mean, for sure, if you have a hard requirement on some security specs or some benchmarking tools, you do need to obviously figure those things out ahead of time. A lot of the conversations I've had at enterprises of like, we have a security spec is like, okay, what are you doing? And like, well, we had a hack on this thing a long time ago, and now we have a requirement to check the box because that thing happened. Even if it wasn't to us, it was to someone else, right? And I worked at Disney when Sony got hacked, and we went through and like audited everything because we're like, oh, what's going on? Like, oh, actually, they mostly ran Windows, and we didn't run any Windows. And it's like, does that mean the security's not a problem for us? No, absolutely. Like, there were still things that we wanted to make sure, but we had to check some boxes to make sure that that was all right. And in any of these environments, if you're deploying this in production, especially if it's going to be publicly accessible by someone, you do need to make sure that the baseline security is there. But again, like I was saying, like a lot of those problems might just go away because you don't have root on a box. You don't have shell on a box. If someone wants to pop a shell, like they can't. It's just like literally like, oh, it's not there. So yeah, figure those out in development. If you want to kick the tires, especially on something like you'll want to do multiple layers. Like the Kubernetes layer is its own security thing, and I think we have a Kubernetes security talk later today. Those are things you'll want to look at as you're going through this, but figure out who's responsible for which layer, because that's a very important thing, and one person's not responsible for the whole thing because there's too much. So, I'm going to take one more because we have this vendor shout out, and I did forget. I think it's in this room. I'm really sorry. We had 3 cancellations for speakers. So if you're looking at the schedule on the printouts, that was printed last week. Look at the online schedule, because unfortunately we had some people that didn't make it and got sick. And so, yeah, please look at the schedule, but I want to give time for the vendor as well.
So I work for an organization that is running on-prem KEDA clusters. We build them manually, mostly through Ansible. I just started about 6 months ago. They're very firmly in the camp of this is cattle, not pets. But I'm the backup administrator. I want to find a way to be able to adequately protect these clusters so that we don't have to try to rebuild them from scratch, something they don't do very often and thus is largely unproven. What's your opinion on that?
The first thing I always ask with backups is what are you trying to prevent? What are you trying like there's data loss, there's crypto jacking, whatever, there's something that's happening that you're like, I need to back up something for these reasons, and there's a reason behind the backups, and usually that's like hardware failure, we get a new hard drive, we have to restore the hard drive. Workloads that took someone some amount of time, maybe days or weeks, to create this thing, now we don't want to have to make them redo that again. And Kubernetes, again, it depends on which identity you care about. And if they're redeploying clusters, if they're redeploying the OS and the workloads, maybe you don't care about the workloads because the state for that is in a database and you care about backing up the database and not the pods themselves. The operating system, if it's ephemeral or if they throw it away, or like some of them are read-only operating systems. You don't need to back up. If you're backing up a read-only operating system, you're probably wasting your time, just because that's not meant to be backed up. It's meant to be provisioned on the fly. But if you're doing disaster recovery, and you're saying, hey, actually, we don't know if our NFS is going to be available when you try to redeploy, and all this stuff pulls off of NFS. So is production going to be impacted because NFS is down? We need to do a backup, or we need to have a disaster recovery scenario to prevent that. Those are the questions I usually ask and say, okay, which layer do you actually care about? Because you can go all the way down to I'm backing up firmware on the boxes, right? Maybe you don't care about the firmware. There's some layer in there that you're actually, this is the thing that I want to prevent. Find that one. There are Kubernetes workload backup tools that'll say hey, we'll suck out your workloads. We'll find any volumes that they're using, if it's stateful. We'll do all that stuff in the Kubernetes layer. There are obviously lots of tools, especially if you're on a VM host, I'll back up the disk, the vdisk, or whatever it is, to get the host. But you might be just storing too much stuff if you don't care about it. But the thing that I found really interesting was the fact that they're treating it like cattle and they're not redeploying frequently. that is something that maybe they're not treating it like cattle. Maybe they do care about something and they just want to think that they're doing it the right way by saying this is cattle. And that's the thing that I would push back on them is, okay, if this is your cattle, I have a new box, create me a new cluster. And then figure out from that, how many things did you not have backed up? Because they're going to have a GitOps repo or something, a bunch of YAML and a bunch of Ansible, and they're going to say, okay, we can deploy it anywhere, anytime. I'm like, okay, how'd the OS get there? Who was responsible for that? How'd the network connections get there? How'd the load balancer get set up? And if those are the things that are the gaps, maybe the backup strategy is automation on other things and not just that layer. So that's what I would push back on them and say, hey, if you say you're doing it this way, let's talk. And let's figure out what we're trying to prevent. So again, I'm around all weekend. Thank you very much for coming. And I want to give, again, vendors and sponsors are why you're here. Please stay for 2 minutes because they paid money and they also want to talk to you and you're probably going to learn something. Thanks, Nick.
Hi, everybody. My name is Nick Walker, and I'm with StormForge. And with StormForge, what we allow you to do is to stop setting requests, because we're going to do it for you. So how does it work? You just install our agent, send up usage metrics to us. We crunch that through some machine learning, and out the other end come recommendations for what your request should be, which we can deploy for you automatically and continuously. So what that gives you is a mass reduction in your toil of having to figure out how to set requests, and for your boss, 40% off their Kubernetes bill. If any of that sounds interesting to you, stop by our booth. We're right outside the door, and really, you don't want to be setting requests anymore. You hate checking those Grafana charts, adding a little buffer. That's how you set your requests, right? We'll do it for you. Thank you.
All right, and I actually don't remember what the next talk is in here. So stick around if you want the next one. We have next door as well, but I'll see you all around hopefully this weekend.
trying to figure out product market fit and messaging. And so we'd love to just give you a demo if you're cool with it. And also show you all the stuff that we have.
Haley, you want to go set up? Yes. Yeah.
But I really think product once you do it the hard way, like that's how I felt, but I will say I couldn't get it working at that. Gotcha. There was like something it's like I had an 18-hour day, and their thing only took about 4 hours.
Battery is low on this one. I asked him to bring the batteries. But try to see if it's working.
I think he gave me most of the answers I was
Still got 15 minutes. One second. And then, does this have to be on my right ear?
Maybe you want to try the other side? I don't know which one.
It's not really a thing. It's gotta be this here. All right, mic check. Sorry.
I don't know if it's working. Try.
Mic check, mic check. Mic check. It's coming through, yeah. Just turn it off for now.
So I'll try to use that. So you said about 40 minutes. Hello, welcome to KCDLA at SCaLE 21X. Our next talk is Gateway API, Basics, Nuance, and the Real World. But our speaker is Lee Capilli, our engineer with Nueva Tanzu, and we'll try to get questions at the end, but feel free to ask questions during the talk as well. Thank you, bye-bye.
That should be coming through. I wasn't fully scrubbed in yet. because I know that we're about 10 minutes ahead of schedule. So if you just bear with me, I'm going to like fix the resolution of some of my demo setups so we can make sure that all my terminal foo is going to go well for all of us here. So you can see I'm also setting up a bunch of browser tabs because we got a bunch of reference material to go through. I'm so glad to be here with you guys for an hour to talk about the basics of Gateway API and how it gets a little bit funky when you start to do real stuff. So thanks for your patience as I just get set up here. There we are. And then we will move this to here. You can see all of my windows are so tiny because I changed my resolution here. So we will up all these font sizes for you guys. Maz, should we be waiting until the 11:15 mark so that folks can actually...
I jumped the gun and I started the thing earlier. Sorry about that.
Yeah.
It's actually 11:15. We can start at 11:15.
Okay. Yeah, maybe let's give some time to get people, like, just let them scrub in and everything. And, cool.
So welcome again to KCDLA at SCaLE 21. Thanks for joining this talk on the Gateway API presented by Lee Kapili. Lee is with the VMware Tanzu team. And we'll take questions at the end, but if you have questions during the call, raise your hand. I will come with a microphone. Please welcome Lee. Thank you.
Mic is dead. Yeah, no batteries coming right now. Okay, cool. I will just put this lav mic away, maybe, for now. I'll just wear it awkwardly. It'll just do nothing, and then maybe batteries will come or something. There's this mic stand. Okay. I should probably hold this closer so that everyone can hear. So we will hold it. Okay, friends. Hey, sorry for the little AV hiccups here. Yeah, I'm Lee Kapili. As Maz said, I do work with VMware Tanzu right now. We were acquired by Broadcom recently, so it's pretty cool to be working on platform as a service specifically now, and kind of our infrastructure stuff has been split out into a separate business unit. That's kind of fun. I grew up here, so I'm from LA. I live in Colorado now, and I love to snowboard. Are there any Filipino-American people in the room? I'm proudly Filipino-American. Hey, I love coming back to LA, hang out with my Filipino people, and go and find some sago later to have some dessert. You might have seen me around a little bit in the Flux project. And then I also used to contribute quite a lot to Kubernetes upstream, especially in cluster lifecycle with kubeadm. Recently, I'm back to contributing upstream. I'm working on some things that are adjacent to Gateway, this thing called reference grant that we can talk about later if you like. But yeah, that is a real picture of my dog. It's not a stock photo. His name is Pepsi, and he's a very good boy. So today's conversation is about Gateway API. I got really excited about the chance to dig in to Gateway because every time I've used Kubernetes at significant scale, it's not been with Gateway because Gateway is pretty new. And I think if there's probably some pretty senior practitioners here, there's a pretty good chance that you're not using Gateway right now, if I had to guess. Because Ingress is perfectly sufficient at the moment. It's probably running production workloads in your environment. There's a million examples. It's a very simple API. And it's really easy to get going with Ingress. You don't have to do anything special. It's like already there in the cluster. And so in order to get into Gateway, there's an investment. There's an investment in knowledge. You got to go and learn the thing. And then you've got to do some extra work as well to get everything working. It's built out of tree. And so beyond the basics, we get into some fun kind of nuancey situations. And then we're going to talk a little bit about a real world topic later that is still very much my crusade, very close to my heart. It's zero downtime deployments. A bit of a mixture of intermediate and beginner content today. Thanks so much for coming. So we have this fancy distributed computer that a lot of us community members have been working on over the past decade. If you haven't heard of it, it's called Kubernetes. And the cool thing about Kubernetes is it's got this declarative programming model. The declarative programming model means that you program the distributed computer in a way that maybe you're not so used to, right? And that seems like maybe kind of a basic primer since we've already been talking about Kubernetes all day. But why this is exciting when we talk about network technology is if you think back just like maybe a decade ago, there was a good chance that if you've ever been a network engineer, you're probably at a terminal in some co-located
data center where you've got like a bunch of loud fans around you and you're hopefully wearing earplugs and you're on that terminal logging into the switch because you got paged and it's 11:30 at night when you'd rather be, maybe like hanging out at home. And you're on that terminal and you are typing imperative commands to first build your mental model of the routing stack and then try to figure out how to mutate the routing stack so that you can get stuff to go the right places. There's a lot of like fancy hardware that you can install physically, and telling that hardware what to do has not always been easy. You usually need a specialist to get in there. So what's exciting is we build this distributed computer, and the API machinery being so extensible in Kubernetes opens us up to this cloud-native world where we can all become basic network engineers. It sounds fun, right? I'm stoked about it. Yeah, I can tell everyone is stoked about becoming a network engineer. So the basic unit of compute in Kubernetes is the pod, right? And just a rough run through on the networking model and why all of this fancy machinery that we're going to be working up to is even necessary, is that pods come and go as they please. We have a lot of them over the life cycle of running interesting workloads on Kubernetes. And they all have individual IP addresses. And so we created the networking API. And there's an immediate split here. That's like an important theme. Compute is separate from networking in Kubernetes. So we make these things called services. And services have a controller that aggregates endpoints. And so it looks at all of the pods of like a particular label using a label selector, finds their IP addresses and collects them into an endpoint slice. We got a bunch of these endpoint slices. We also mirror it to the endpoints API so you can keep using that thing, which is old and technically not supposed to be used anymore. This slide is technically wrong. And now that we have these endpoint lists, we can keep them dynamically updated, right? And so we're always just watching, and then we do our best to keep that list up to date. And then there are a bunch of things from the ecosystem, from the core Kubernetes cluster, maybe from your data center, from some random bash script that you might be running in a CI job, that might be interested in all of that networking information. And traditionally, it has just been nodes, maybe a cloud provider load balancer, which is like a type of service. You just decorate your service to be a load balancer, and now it goes and does fancy controller things in your cloud that you pay a lot of money for. And then you've got the ingress controllers. So ingress was kind of the first community effort to extend Kubernetes in a way where we brought kind of the first application-facing protocol abstraction into the Kubernetes API. So we're beyond actually compute, and we're beyond networking, and we're into the protocol layer, which I guess is part of, it's a higher level networking layer, right? And so what did the ingress API look like? Well, if we hop over to VS Code over here, and let's just pull up a rudimentary ingress YAML. Okay, so here we have the networking API. We named it Nginx. This is defaulting into the default namespace, which is a terrible API decision that we all regret. And then now we have a specification. At the top level of the spec, we are going to have a list of rules. Those rules then can have these kind of protocol entries, and then within those protocol entries, you can go into paths, and then you can decide if that path is going to match on some particular conditions, right? So this one is a prefix match on the root slash, and that path, when it matches, is going to go to a backend. So, you know, if I wanted to be all fancy and stuff, right, I could like make 3 of these, you know, and then start sending them different places, right? Like maybe this one is the Nginx for the store, you know, and then maybe this one is the Nginx for, you know, the app layer, right? And then, you know, we can like change port numbers or whatever. And then we would maybe say this is the, you know, API v2, you know, and then this would be the store cart endpoints or something like that, right? And so what you're getting here is something that looks awfully like a reverse proxy configuration. And that's exactly what the Ingress API is for. It is a reverse proxy. That is the old term, and now we call it Ingress and Gateway, because that's the cloud native like jargon. This is a reverse proxy config. We have a single listener somewhere that's then being multiplexed based off of the content of the packets that are flowing at the protocol layer. The reverse proxy is responsible for watching those packets, consulting its configuration, and then deciding where to send those packets and how to modify them based off of the config. And so we're kind of fanning out into multiple services. And you can make a bunch of these, so that's kind of fun. We start to get into a couple of problems here. And to illustrate problem number 1, I'm going to go to the Kubernetes documentation, which is here. So this is like the first touch point of the Ingress resource in the Kubernetes docs. I'm kind of wondering, this is like upstream Kubernetes docs, and for some reason we've got an example here. I guess it's a good example, honestly, because this is how Ingress is always used in practice. You hardly ever see an Ingress resource that's not annotated with something. And these annotations in the Kubernetes API machinery are how we can start decorating resources to have additional metadata so that something that Kubernetes core doesn't control, like an Ingress controller that comes from the community, can get more data about the resource and what its declaration is supposed to be. It's basically an API definition outside of the API definition. Ingress is one of the few APIs where this really matters, because there is an Ingress class resource, which maybe, sorry, I didn't pull up an example of this. Here it is, Ingress class. So there's Ingress and there's Ingress class. Interesting, right? And that's because Ingress was built as a specification that was intended to be implemented by a bunch of people. And if you look at the CNCF landscape, you can see that that intention ended up being very successful, because we have a ton of Ingress controllers inside of the ecosystem. It's super exciting because they get to bring all of their features, and by the time you end up using an Ingress resource in the wild, this simple example of a single annotation frequently ends up being like 12 annotations that are being operated on by 2 or 3 controllers. Often it'll be like your Ingress controller and then like external DNS, and then maybe also a cert manager annotation in there to tell it like which issuer that it's supposed to be using, and like what domain name it's supposed to be like being put out into Route 53 or whatever you've configured with external DNS. And so this is kind of problem numero uno. Sub-problem of that as well is, because we invited a bunch of people to extend this thing, we realized, oh, this is a pretty decent core subset of reverse proxy features, but it wasn't enough. It's never enough for anybody. And so the path prefix matching needed to then like be broken out to support wildcards, and people started doing that in annotations. And then people wanted to start supporting sticky sessions, and they started doing that in annotations. And the annotations got so sophisticated. Let me pull up traffic for you. Traffic. Check this out. This is so fun. I have used this web page so many times in my life, more times than I would want to. Yeah, this is an annotation, but it's like structured. Like, we've got router.entrypoints, router.middlewares. You know, you can set the priority of what this ingress rule is going to be using. These are all annotations that are meant to be used on a Kubernetes ingress. And only traffic understands them. So then traffic rightfully got tired of this, and then they made their own custom resource. And Contour got tired of this, and they made their own custom resource. And so it was really clear that ingress wasn't scaling for people. Also, there's something sort of insidious happening here. We're mixing a lot of concerns into one object. One of the nearest and dearest things to a developer's heart is that traffic would arrive at their application. And nobody knows better what path to send things on and what port something should show up on than hopefully the developer of the app. But a lot of devs, I know when I started as a software developer, I was not a network engineer. I did not know that SSL certs were actually supposed to be called TLS, which is a different hill to die on, right? I didn't know what a network CIDR was. I wasn't sure how to provision IP addresses in the public space. That seems like a rare skill still. You know, there's a lot of like very special skill sets in order to actually do real networking out in the real world. That's why we specialize and we help each other out. And so it would actually be really nice if all of this stuff that we were putting up here could be owned by a different resource. And that is pretty much exactly what we did with Gateway. The third and last problem that I'm going to point out as I complain about this beautiful object that has literally revolutionized the networks of many enterprises is ingress is lacking precision in one more place. And that is that when you install an ingress controller in your own cluster, you often can pick where that reverse proxy lives, the actual infrastructure of it, you know. And so you could put that on an edge node in your data center. You can run it as a fleet of pods on your nodes and expose them via node port. And you then hook that fleet of endpoints up to an ingress class, and then people can select into it. And if you want more of those, then you can deploy more of them. You make more ingress classes, and people can keep selecting into them. And so developers can be like, I want this route on the internal network, this route on the external network, this one on the CDN. You know, and get the benefits of all of the fancy arcane configurations as long as I keep passing the same set of annotations that people tell me to do so. But then you get into a cloud provider, and they were trying to provide these awesome products. Like, I was using a lot of GKE at the time, and I'll be pointing to a lot of GKE docs. Today I don't work for Google, but today I am, I guess. And the moment that you wanted to deploy a global load balancer, the GSLB, you created an ingress resource, select into their default ingress class, and now you're paying like $20 a month for that thing, and it's routing like one service in one namespace. Now, you were able to then go and make another one of those in another namespace, and now you're paying $40 a month. And there wasn't a really great way to divide tenants up across namespaces and reuse the same load balancer with ingress. And so, especially with cloud providers, they ran into this like I have to have these one-to-one mappings of expensive infrastructure to the things that I'm routing to in the cluster. When you start to get into people with like very multi-service architectures, I don't want to say microservices, right? Like it just wasn't very cost-friendly, and a lot of people ended up just rolling their own stacks of self-managed ingress controllers just so that they could get the proper service mappings to their namespaces. Okay, so the hierarchy of our organizations always wins. But cool. So thank you for listening to me rant about something that we probably a lot of us use. There's some growing pains that we've all run into, and that is why we are now in the beta after several years of Gateway API. Let's go take a look. Hopefully some of you are already familiar with Gateway. If you've never touched Gateway in Ingress or Kubernetes, hopefully we can also present the info in a way here where we can all learn something. So just coming back to our little slides. The really fun thing with Gateway that we realized was that second pain point. The stacks of annotations were building up. People were starting to have to build their own APIs. There's fragmentation happening in the ecosystem. And everybody had to use all of it, and it got all mixed up. And we had these single resources that were owned by multiple people, right? You had infrastructure people saying, hey, the ingress class, points to this thing, so you need to know that. And then the ops folks were like, okay, we gotta make sure that we configure the proper wildcard redirects and header overrides and stuff in here. And then the devs were like, I'm trying to manage my paths and port numbers and like direct to my service names because I just added a new one. And it's all in the same object. That's not working well. So in Gateway, we really focused on 3 personas. Right? There's the person who provisions the infrastructure of the gateways. There's the person who operates the cluster, who decides how stuff gets divvied up, how stuff is configured at the networking layer. And then we've got to serve the application developers so that they can own their part of the config without having to worry about all of this stuff that they frankly shouldn't even have to be concerned about knowing about. Right? I'm all for people learning new skill sets and stuff, but if somebody's not trying to be an infrastructure network person right now, they're just trying to solve business logic problems, let's let them do that and not tell them, here's a 70-character long YAML string, that you need to indent in the proper place in your service definition, right? So, Gateway is multi-persona just by design, right? And you can see that if you go to gateway-api.sigs.k8s.io, you will see that right up front, right? Now, we get our first look at the Gateway API resource model. So not that many more objects. I guess you mostly had to worry about 1 before, and now there's 7 technically. 8, there's 8. And so we got our classes, which is similar to Ingress class from before, new and improved. We have our gateways, which this is basically the replacement for the top part of Ingress, where all of those annotations went. Right? So now we can configure TLS certificates. We can do all kinds of fun, hacky, networky stuff to transform packets in the configuration of the gateway. And then we can hand off to our application developers who will say, hey, I've got a route on some protocol that I would like to expose. I want that to live somewhere in a namespace that I own, and please aggregate that up to some gateway. If I don't specify, please try to figure it out for me, or let me opt into some stuff. So that's cool. If you then hop into the Kubernetes docs here, we have a concepts page on Gateway API, where you can start to see how these things look. So with Gateway classes, we have this example class, and then it ties into a controller name. So the way that the spec recommends that this works, because we can't force anybody to do anything, but we can say, hey, please be compliant with the way that it should work, is controllers will load up all of the gateway classes, filter them out, and then look for themselves in their classes so that the infrastructure provisioner of the cluster can decide which classes you need in a cluster. So if you want a local load balancer class, and then a CDN load balancer class, and a public internet load balancer class, the infrastructure provisioner of that cluster can decide at that time. And then it can assign it to the gateway controller to go and do stuff. Yeah.
Just for that, I love the topic. I want people to also, on the previous slide, you had 3 concerns, and I think there's also another one where there's security that needs to review reports that you use.
Yeah, I think security is often owned by the cluster operator. I realize now that I haven't been speaking into the recording, so thank you so much for calling that out. I'm going to try to remember to hold this mic properly, and maybe I'll just take this off, because it's like muscle memory at this point. And, all right. Great. Thank you. Okay, so gateway class looks pretty similar to before. Now, I'm going to go and pick on GKE here because they've got some really good examples. Oh, actually, it was not GKE in my head. It was, I think, on this page. Yeah. Now, what's really improved about this is we've put a lot of effort into parameterizing the gateway class so that if you would like the infrastructure provisioner to be able to tell the gateway controllers how particular classes of gateways, anytime you instantiate them, should behave, you can add some configuration in the parameters references here. And this config can actually reference any sort of custom resource that you add to the cluster. So this is a great place for traffic to add a traffic config and contour to add a contour config because they can read their own schema and then decide how classes behave. So pretty awesome API decision here for the people who maintain these ingress and gateway controllers. Gateway class gives you some ability to vary the configs. So that's kind of the first step. Now next, we'll just put that away. Next on that chart, we were going from gateway class. Now we're going to make gateways that reference some gateway class. Every gateway has to be classified. This is the main tool that we use to help support multiple implementations of gateway controllers running in the same cluster, because now we can subdivide the API up amongst those controllers. And so with gateway, if we go to the API spec, you can see that, sorry, this was this example right here. So they start out pretty simple. This is the cluster operator now, saying, okay, my infrastructure provisioner has provided me some classes that I can select into, right? What would that look like in the real world here? If I go to the GKE documentation, this is why I was going here. There are a lot of gateway classes that you get from a Kubernetes provider's cluster. It's like the muscle memory is like not working with the one hand. I don't even know how to type anymore. Cool. All right, and I'm looking for internal gateway classes, and then I'm looking for this doc right here. Gateway class capabilities. This is a wonderful table. So they've got, I think, 8 gateway classes listed here that are potentially usable inside of a GKE cluster if you just spin one up. You're going to get a similar experience if you spin up a gateway compatible cluster from some other infrastructure providers, such as Azure, or if you purchase something from one of the big vendors. And you can see that these gateway classes, some of them are multi-cluster classes, some of them are managed load balancers, others are various kinds of application-specific load balancers, and they all have some very interesting feature sets that you're able to configure with different policies that you reference inside of that parameter config. So all of this is done for you by default ahead of time. So I come into my GKE cluster, I just bought this thing. I'm like, okay, now I want to opt in to using some gateways. So I'm not paying for anything off the bat. But I have all of these configurations available to me. That's pretty cool. It's like I got a little catalog from the person who was provisioning my cluster. So I basically go and make my gateway, and then I select my class name. And then there's some kind of core fields here. It's listeners and addresses. And again, it starts out pretty simple. You can actually see in my demo repo, I'm going to be using something that basically looks exactly like this. But again, this is a great place for somebody to make some choices. And so when I actually make my gateway, yeah, I'm picking the ports, I'm picking the IP addresses that it's using. And if I kind of grep through for some examples here, right, this is kind gateway. And then, so here's a gateway class being picked here. You're still seeing some patterns of using some annotations to like, hook up to a structure that GKE knows about. But then, like here, we're using the address struct. And then it's using this named address, and that's actually going to use a name that means something magical to GKE. But look, it's an official part of the API. That's pretty cool. And then here as well is a static IP address example, right? So that would be the cluster operator experience of now provisioning some gateways that can then be used in the platform that I'm now implementing on the cluster that I just purchased. Very nice. So lastly, we've provisioned some actual reverse proxies, right? Like I have gone in, I've decided, hey, I want to use 3 of these gateway classes. I want something on my VPC. I want a kind of CDN capable gateway class to serve some assets. And then I also want a fancy multi-cluster, XDP powered, like nearest neighbor, nearest path routing kind of load balancer product. So I picked these 3 things. It's like my global load balancer, my CDN load balancer, and my VPC internal load balancer, so that I can talk to internal services. And I made these 3 gateways, and still nothing is being routed, right? So we've just set up all of the cluster infrastructure with the 2 personas. The third persona is those application developers, right? So now we're actually getting to real business value almost, right? The only thing left for the app developer to do after they create these HTTP routes and TLS routes is actually do something valuable inside of the software that's running behind those routes. So that's like always the funnest challenge, right? And everything else is kind of just a slog, but we get to pretend to be network engineers. So the HTTP route resource is kind of it's going to be the most common one, I think, that a lot of people are going to be reaching for. And then TLS route is also going to be quite nice if you're looking for some MTLS kind of encryption in the cluster. So let's look at an HTTP route. I have an example of one of those. Not this. Let's go to our gateway example that we will be demoing in just a moment. So you can see I have a class here, and then I've provisioned the gateway. Unfortunately, I'm all 3 people in this example because we're a very small startup. So here's our HTTP route resource, right? So we're not doing encrypted HTTP in this case. I could have added TLS termination onto this gateway, but we skipped that for the moment. That's easier to do with a managed provider, of course. And this HTTP route, it looks kind of suspiciously a lot like Ingress, which is nice because people know how to use Ingress. There's plenty of examples. You probably have 50 YAML files of ingresses inside of your control repositories, and converting those is already a significant feat. So some stuff has changed here. We've changed some field names, and we've made things a little bit more capable. There are also a few deprecations, like prefix is no longer a proper word to use here. You have to say path prefix. You also will notice here that you can specify parent refs. So as a developer, if I leave this out, right, then it's kind of just up to the gateways to figure out if they should use my HTTP route or not. I could come up into the metadata section and I could start labeling my HTTP route, and then gateways that are using label selectors to filter down what they want to route can do that. You can also do it at the namespace level. You can also have multiple gateways reconciling the same sets or intersecting sets of HTTP routes, which is actually exciting because you might want your service to be reachable both on the CDN and from the internal VPC gateway. So you can see now that there's a lot of power here in separating the HTTP route and the gateway. Because now we can create one-to-one mappings, we can create many-to-one mappings, we can create many-to-many mappings, and do whatever level of sophistication is justified by our application's needs, or more likely the complexity of our interpersonal relationships in our growing organizations. So, you'll see that this is kind of a protocol-specific one, and what's fun is if you hop over to the gateway reference. We don't have this here. We have it, where was that? I'm sorry I'm fumbling so much, friends. I'm like so much slower here. So here's an example of a gRPC route. All right. I am not a person who's ever used the Google RPC. I've only ever interacted it when like talking directly to etcd, but I do know that there is a small but growing community of people who are trying to even serve gRPC to public endpoints and do fun stuff on it. Of course, inter-service communication is kind of the main goal of gRPC, and so we support gRPC route in Gateway. And you can still do the same sorts of things like rules, matches, filters, and you can send them to the particular gRPC backends. And then it is up to the gateway controller to then support this optional resource that you can install in your cluster, and then know how to multiplex on gRPC. You know, needs its own stream processing and load balancing algorithms. Cool. We are doing pretty well on time here. Great. Well, this is a pretty high-level overview of the basic objects of Gateway API. Unfortunately, you can see that you already get into a lot of nuance with anything that's designed to be used by multiple implementers, right? And that is both the challenge and reward of going on a multi-year effort to ratify an API like this. Some gotchas are that as soon as you want to use Gateway API, if you have just spun up a core Kubernetes cluster, you're going to have to go install the API. So when you first spin up Kubernetes, Ingress is just sitting there and it's waiting for you. But Gateway is one of the first kind of very core intended, very official APIs that doesn't come pre-installed in Kubernetes and is not some feature flag that you can just turn on in the API server. It is actually shipped as a custom resource definition. The reality of using Kubernetes for anything real these days is you probably do need to install a custom resource definition. They're just shipped from the GitHub releases in this case. The custom resource definition is going to be separate from the gateway controller that you're going to install. So you're installing one thing from one place and then one thing from another place. That's kind of maybe a little bit of a mental switch, but they are often separate life cycles anyway. Installing a controller and installing the API the controller needs has to happen before that anyway. So let's get into a little discussion of some things that are developing. If you go to this API types, you can find this little button on the side here that will take you to this page called Reference Grant. Reference Grant is something that I'm really excited about right now. There is a problem that you run into when you want to start configuring infrastructure that needs encrypted or secret bits. Say we install a TLS certificate into a secret in our cluster. Now we have the ability to configure something to use the private key to serve some secure connections. We need to tell our gateway controller how to get to that certificate, and we need to give the gateway controller access to read that certificate. The sad state of affairs is that RBAC is technically good enough to solve that problem. but where we've ended up in the community is that most ingress controllers that we install these days, and subsequently we add gateway support to these ingress controllers, so now gateway controllers, it's basically become a canonical pattern that these reverse proxies that live on the very edge of your infrastructure have access to all and every type of secret thing inside of your cluster. And that's not great. It's a pretty big attack surface. These are the first point in which bits transfer into your network from a source that you can't control. An exploit in an ingress controller could suddenly mean an exploit on all secret things that you keep inside of your cluster. And we should fix that. Unfortunately, the path of telling everybody to do it a different way has kind of sailed. And so what we are trying to do is build mechanisms, build the fundamental mechanisms to start allowing APIs to have granular referential access. The source of reference grant is actually to try and do cross namespace stuff. So here we have somebody who owns a service, and we want to make it possible for the person who owns that service to opt in to allowing the route to point to it from a different namespace. Now, you can see that the same concept would be useful for secrets, and it would be useful for any kind of back-end configuration that needs to point across namespaces. It can also be useful for gateways and collecting routes, whether they should have access to those routes. And this API design is very desirable, not just to networking APIs. SIG Storage is looking at using reference grant. And then Flux, a project that's pretty far outside of Kubernetes core, has additional needs around cross namespace references. Typically, you see people making customizations or Helm releases. Sorry, I'm struggling for that word. Releases that need to point to some source, right? So like a customization to a Git repository, a Helm release to a Helm OCI repository. And those sources could often be collected in some central namespace, but then you want to release them in namespaces that other people control. And so this is a very fascinating and developing area. And reference grant is already an optional component that you can install with Gateway, and some Gateway API controllers support it. And we currently just trust the Gateway API controller to follow the references and to properly implement the access controls. What we are working on now is a KEP for referential authorization, extending or maybe even being built into the core API server. And so this is really getting into nuanced real-world edgy stuff that doesn't work yet. We just have a barely working proof of concept prototype. This is KEP number, I think 3766 is the issue link. So that's probably the KEP number if I remember how that works properly. We've been working hard on this. It is collaboration between multiple people for a long time now. And we are speaking about it at KubeCon and are going to be trying to continue ratifying this API into something that is generally usable for multiple projects and can be authorized by the API server so that we can fix that problem of ingress controllers having access to literally everything that's important. So that's just a little bit of nuanced bits there. I'm going to take a step back here and go to a more lighthearted place, which is something that I think everybody can appreciate, a live demo. So if I hop over to here, and let's see how this goes. I might need this. So right now, I have a kind cluster. It's, you can see it's just running core DNS, etcd, the normal kind CNI. We've got API server, controller manager, and the proxy scheduler. And then I've got a traffic controller. It says ingress controller, but I'm not running this in ingress mode. Ingress is not even enabled. It's purely configured for gateway. And then I'm not using this storage provisioner right now. So then if we take a look in our configuration directory, we can see I've got a deployment that's running my traffic controller. Maybe I could rename that to gateway. And then it's running just the latest version of traffic because I don't like updating the tag every time I have to do this demo. And then, yeah, we can see I've disabled ingress. I've disabled their special custom resource. And I'm enabling their experimental gateway support and then enabling the gateway provider. And then this container is just going to expose on the host port of this single control plane node that I'm running. And if we then look at the application that I'm using, I'm ironically using another web server / reverse proxy as my app. So it's just Nginx, a common little demo app for somebody who doesn't write too much customer-facing software anymore. This is just a deployment of Nginx. You can see I've got a bunch of replicas here, which will be useful. And then here's my rolling update strategy, which is pretty much default. I've got progress deadline seconds to 600, just labeling it with a version so I can constantly change out the pods when I change that version number. And yeah, termination grace period. So nothing else happening in the container spec. It's very just vanilla, latest version of Nginx. So if I look at the, oh, I'm sorry, I glossed over this. This is the CRDs for Gateway API. I am using an older version because my gateway controller of choice in this demo only supports Gateway from like 2 years ago. So, but it's good enough to display these concepts. So we've also got the RBAC. And then here is our gateway configuration. So we looked at this earlier. We declare a gateway class. We have to tell traffic, hey, my local gateway class, would you please control that? And then as the, so this is kind of infra provisioning. Now this gateway is available to be created as a class. And then I want to select into that class and make a gateway. If I wanted to, I could make multiple of these and try to put them on different port numbers. In my kind configuration, I have that port forwarded here. And then now we just are going to be creating a single HTTP route resource, right? So this is something that you could break out into your apps folder. You can make a bunch of these. You can do all kinds of rules matching here. You can put them in different namespaces, and you can select them into that traffic gateway, right? So the gateway is named traffic here, and then the parent ref here is traffic. The traffic gateway is of class local. Cool. Well, I've already applied this directory to the cluster. That's just kapply dash customize and then the folder name, which is Kate's. And you'll see that we can just curl localhost, and then that is the Nginx homepage, or default install. Cool. So what can we do with this? We can point out some problems with default Kubernetes behavior, which is always fun because you would think that when you install a state-of-the-art distributed computer and you start using it the way that it's documented, that it would be like a good thing to do. Let's show that that's not the case. I'm going to start a siege. Siege is a command that just batters my web server with requests over and over and over again. So it's basically just doing that curl more times per second than I could with my own hands. And if I stop the siege, you'll see that we get some statistics here, right? So, you know, on a state-of-the-art little MacBook here, we should never fail a request. Right? This is a very reasonable rate of requests to be serving. All right, let's go and try to do a rolling update, which is like the quintessential Kubernetes demo, right? Roll the credits. And then I need to, let's just get everything visible here. Okay, so I'm updating the label here. Thank you, Mas. Okay, apply -K. My Kubernetes, oh, what just happened there? That's not good, is it? That's a 502. What's happening, friends? That's not cool. So we talked about all this stuff. This is like the worst thing to show up in a user's browser, isn't it? Has this ever happened to you? Raise of hands. Yeah? Oh no, that's not fun. Yeah. Pod shutdown. So the Kube API server has a bunch of legitimate reasons to receive a delete from a controller. Like when you do a rolling update, you got to delete all the pods that were there before so you can replace them. Makes sense. The pod gets marked as terminating. Asynchronous consequence of that is the service controller has to remove the endpoint of the pod. Sounds good. Remember how like we try our best to keep the endpoints list updated? Of course, that takes some time. But the Kube API server is really good at getting that information to the kubelets quickly, right? And the kubelets, they're like, oh yeah, okay, like I'll just run any pre-stop hooks, and then I'll go ahead and send sigterm to PID1, and then maybe something reasonable will happen. It's not configurable, but hopefully your application does something good. It does something good maybe about half the time. And then termination grace period seconds starts, and if that termination grace period seconds ends and PID1 is still in the process table, then the kubelet will just be like, yoink, I'm going to kill that and rip it out of the kernel, please. And so that's kind of how pod shutdown works. The consequence of that is that most apps don't do the right thing when they receive a sigterm. Usually, you know, back in the old days when you like logged into the reverse proxy and manually edited the Nginx config, like you would open up the logs and you would check that the traffic drained before you killed the process. And that's usually not what happens. So you've got to do this thing called a pre-stop hook. Either that or you have to change the way your app is integrated so you can configure it. So the issue here is we've got an endpoints list. We've got a bunch of things in our network like gateway controllers and kube proxy and a bunch of, you know, maybe NF tables and then some BGP lists inside of your router and then there's like maybe some other controllers like the cloud provider load balancers who are trying to distribute all of the IP information about this pod, this thing right here. It's got an IP address. It's getting propagated to all of these places distributed everywhere around your network. There's no way you can know what the state of all of those things watching for this IP address are. And then we mark the pod as terminating. And kubelet wants to shut it down. And so it gets ripped out of the endpoints list. But nobody knows yet because they have to get that information. But meanwhile, we've already marked the pod as terminating. The kubelet has noticed. And now maybe this node has found out, but now the pod has shut down. It received a sigterm and then just immediately quit. And the gateway controllers and kube proxy and some router that's still like on that BGP advertisement, they're still getting that information to send packets your way. This is a really bad situation. That's where those 502s are coming from. Another creepy thing happens here actually, if I just do this one more time. I usually, oh no, rainbow wheel. What is happening? Okay, here we go. And then, if you like just let that sit there for like 25 seconds, like you notice we're hung. Like I can't even make any more requests, even though there are pods that are running available to serve requests. And it's because I'm waiting for a TCP timeout. And this will happen in a user's browser. And you really, really don't want that. It's a bad experience. If you wait a few more seconds, it kicks up again after the TCP timeouts actually time out. There you go, right? So people will be like, oh, I can fix this with probes. So I made this patch over here to just add probes. Right, there's a liveness probe, a readiness probe in here. You got to be really careful with liveness probes. They're super dangerous, by the way. Make sure you just really ramp these numbers up so they don't run that often, or just comment it out. But people are like, oh, this will fix it. It's not going to fix it, right? Readiness probe is going to prevent your application from receiving things when it's not ready yet, when it's starting up, or if it needs to temporarily close its doors. But when you're shutting down, this is not even looked at. People say, oh, you got to fail the readiness probes in order to make it start shutting down cleanly. That's not the case. It's not needed at all. I'm not going to show the demo because we're getting a little bit short on time here for this. But what I will show you is the way to fix it. In Kubernetes history, we've always had to do this patch. You might be familiar. It's the pre-stop exec command. And then you hope that this binary is in the container. And then you tune your network by doing some very sophisticated science, which is like watching logs and trying different numbers. And then that is how you make stuff work at a production-ready level. You will find this in every legitimate Kubernetes cluster that's running services. I have news. I've been complaining about this and not doing anything about it because it's hard and it requires changing the pod API for years. Tim Hawken opened an issue and then a bunch of volunteers got involved and they made an 81 file change to Kubernetes core and then documented it and released it in 129 as alpha. If you go to my kind config in this repo, I'm on the gateway branch, by the way, there is feature gates, pod life cycle, sleep action. You can turn this on. It's off by default. And then you can go to custom probes over here. And sorry, you got to go to the alpha folder. You can do this. It's beautiful. All of that work and years of complaining, and now you do not have to, you basically write the exact same thing, except this number is a real number, not a string. It's validated against termination grace period, and you don't have to rely on the existence of a binary. This is the best thing that's ever happened to the pod API. I'm so excited about it. Let me show you, it works. It is so good, all right? Let's deploy the alpha configuration there, get all those pods rolled out, we'll run a siege, and then we will go into the deployment, and then we will say, hello, SCaLE, 0 downtime. Okay, do this, let's roll it out. Look at that, like they're sleepy. The pods, they're so sleepy. They're just terminating there for a long time. And then they fall out of the endpoints list. And the gateway controller finds out about it. And it's just continuously sending traffic to the stuff that it should be. And then eventually these things just go away. Beautiful. I love it. Yeah. I got a story to tell you real quick before we wrap up here. Yeah. I was so tired. I could barely give my update as stand-up. Every app update had this intermittent state where the pods could barely stand up. Read O'Reilly and I was ready. Kubernetes looks so steady. Turns out I was overzealous because my merge request is sending every rollout I am checking. I'm seeing 503s. I'm digging every hole out till I heard this song from Lee. See, this wrinkle seems simple when you muster up the principle. A multi-node cluster network cannot be invincible. And service and endpoint, the root of the point. is controllers need them slower cause computers disjoint. I was tired, could barely give my update at stand-up. Every app update the intermittent state where the pods could barely stand up. Hands up off the keyboard, I shipped a policy just to hook a simple 3-word pre-stop bin sleep. Now the users are hammering, I know I'm sleeping sound. The pods are stammering, but like kublets are sleeping now. See, this wrinkle seems simple. Muster up the principle. Multi-node cluster network cannot be invincible. Service and endpoint, the root of the point is controllers need them slower cause computers disjoint. My ingress controller comes with a gateway class. Then I made myself a gateway. Now I got myself a pass. So fast, deploy my apps. Check the graphics just as planned. Devs cramming one more YAML so their traffic is just passed to their main route handle. Not needing any brandle. No stress. TLS, DNS, and no mess. HTTP, TCP, UDP to quadruple. Got a protocol tuple with that RPC from Google. Platform is simple, a gateway repo, infra ops dev in persona trio. This is Lecap with a recap. To the rhyme is how you know this is Gateway API. Let's let the traffic flow. Right. Thank you for listening to me rant.
Thank you, Lee, for such a nice talk and presentation and demo and song. We don't have a lot of time for questions. Maybe take one or two if there's any.
I guess there's break right now, right?
Yeah, true. But before you leave, we wanted also to give the podium to one of our sponsors, Mike.
Thank you. Thank you, Lee. That was, I don't even know what to say after that song. I'm so impressed. A rap at a Linux conference, that was great. Thank you. Well, I'm Michael. I'm here from Percona. We're one of the sponsors. We do MySQL, MongoDB, and Postgres databases. We're happy to announce that we've got some operators that are available for each of these 3 database technologies. We're going to be in the Expo Hall in booth 117. We've got monitoring software. Everything is open source, free to use, no licensing, no nothing. Come see us. We'd love to talk to you about your database challenges. And thanks, and have a great day here at SCaLE.
Thanks everyone for joining. The slides will be on the website, on the SCaLE website. Please make sure to take the survey, attendee survey. That would give you a chance to earn some free CNCF training. Thank you. I'm sorry, the next two presentations are canceled in this room. You may want to check the presenters canceled, they couldn't make it. You may want to check the online agenda. I think the next scheduled talk in this room is at 3:45. So please check the agenda, but as far as I know, the next two presentations are canceled in this room. For the presentation couldn't make it. Sorry about that.
you got a few minutes, and yeah.
Hello? Can everybody hear me okay? All right.
You don't get a monitor, we hear you.
I'm sorry?
You don't get a monitor back to hear yourself.
Yeah, you don't, which is kind of nice too, because I don't like hearing my own voice. Okay. Huh? I think you'll be fine with this when I switch it. The video runs. It's when you try to go back to PowerPoint is where it doesn't like it. Oh, well, the sponsor thing, which one is before, like each? would it pick up my stuff? Like, am I gonna be, should I just step back? I don't know. Yeah, you're gonna put it next. I just feel like I need to go here. Don't move around too much. That's what the instructions say. Yeah, it goes, even everything is set against, like there's nowhere to move even if you want to. Don't fall off. Don't fall off, good.
Let's do this so they can have it. Hello, thank you for coming. Sorry again for the cancellations today. This is the last talk in this room, so we can go as long as we want. Ask all the questions you want. It's going to be a great talk. We are going to do the two other sponsor shout-outs right now so that we can make sure that you can, if you didn't get a chance to talk to them, you can at least hear from both of them on what they do. So I'll pass it over.
Thank you. Thank you for letting me talk first. Not competitors. So, yeah, our company name is Willa, U-I-L-A, first table on the left, and my partner here is, our adjacent company here, co-sponsor of the session. So what we do is observability for whatever you wrote out to AWS, to your on-prem, or to your other cloud platform, either it's VMware environment, Kubernetes environment, Nutanix, or what have you. We provide that observability in the production environment. So if you have user complaint, application slow down, that you got into the finger pointing situation, couldn't find the root cause, we're the one tool that can, help you, make your life easier. So, yeah, thank you.
Thank you. Hi there, my name is Henry Campbell from Tigera. If you're not familiar with Tigera, we own Project Calico, which is a popular open source tool in the Kubernetes space. It does container networking and network policy. At Tigera, on top of that, we layer on additional security and observability tools. To help kind of reduce the attack surface in Kubernetes environments. We typically work with platform teams or cloud platform teams to take a zero trust network security approach to Kubernetes. Essentially kind of a default deny, selectively allow traffic that's required for your applications. We work with any Kubernetes distribution, any cloud, working with some of the largest banks, some of the largest telcos, healthcare providers in the world, and we also work with SMB mid-market. Anybody that's using Kubernetes and you're looking to accelerate your deployments, reduce the amount of risk, and also observe and troubleshoot your security posture, Tigera can help you. And yeah, we're next to Willa, just out the door to the left. If you guys have any questions or curious about anything, we're happy to help.
Thank you both, and thank you for sponsoring KCD-LA and letting everyone come here. And thank you for closing the door. Perfect. So we have Christina and Apurva giving the talk on vending machines for data science experts. Yeah, we'll let you take it away because I'm sure other people will have questions that I cannot answer.
Thank you, Justin. Hi, everyone. My name is Christina Andanov. I'm Solutions Architect at AWS, and I help customers build platforms on Kubernetes.
Hello, everyone. My name is Apurva Kulkarni. I'm also a specialist SA Solutions Architect for containers. I help customers of AWS adopt machine learning workloads on Kubernetes.
Let me take you back in time to the beginning of 2022, when almost nobody knew what ChatGPT was, and AI/ML was on no executive's priority list. At that time, business applications were the priority, and organizations had a platform team that created Kubernetes clusters, and application developers installed application on those clusters. And at that time, if you got hired as a data science engineer, and you went to that platform team and asked, can I have a Kubernetes cluster to run my ML workloads on? The answer usually was, sorry, can do. We have business applications to run. Instead, here are the keys to the kingdom. In other words, the keys to an AWS account. I'm sure you'll figure it out. And those keys don't look as nice as this one. They actually look like this. And at that time, if you were that data science engineer, you would start wondering and reconsidering your life choices and wondering, was that PhD really worth it? A few months pass by, and the company hires a few more data scientists. And they also hire an embedded DevOps engineer for your team. And life is better with company, and with everybody's help, you're able to run a couple of machine learning workloads in that account. But it's not easy, and still the question's like, was it worth it? And then, one day in November, that same year, everything changed. And now priority number one on every executive was AI/ML. And now, that no can do turned into, let's see what we can do. So let's see what the platform team can do. They already built Kubernetes clusters for developers, and they also set up the add-ons on those clusters, including the tooling for developers to deploy business applications to those clusters. So now they would not start building clusters from scratch. They would actually reevaluate this platform that they already built, most likely in Terraform, to see how they can repurpose it for data scientists. And the first thing they should do in this case is go to the data scientist and ask, hey, what are you trying to do? What do you want to run? And the data scientist will say, well, actually, it's not one thing. I want to be able to run a variety of experiments. I want to be able to do data transformation and processing, inference, fine-tuning large language models, and I want to use this open source framework called Ray that is a Swiss Army knife when it comes to running Python workloads. Also, I want to be able to run multiple experiments at one time. So as a platform engineer, you can certainly install Ray Operator, and you can set up the tooling that the developers install the business application with for the data scientists a little differently, but they can, you can set it up so it installs a namespace for each experiment and stands up Ray cluster and Jupyter Hub. And then they can set as many namespaces as they need that way. So I know I brushed up on Ray Operator and Ray cluster, and Apurva is going to tell us a little bit more about Ray.
So, show of hands, how many of you have heard of Ray or used Ray in some shape or form? Cool. So for the rest of you who are not familiar with Ray, Ray is a distributed, is a Python framework for running distributed applications at its core. And it has some higher-level libraries for you to be able to run training jobs or to be able to do fine-tuning, hyperparameter optimization. It has an inference capability through a library called ArrayServe. And because it was kind of born after the Kubernetes era, or it was kind of born during the same time out of UCB, they built it up, ground up, to be able to run on Kubernetes, which is great for us, right? So now we can run these Ray jobs and Ray clusters on top of Kubernetes. And the way it runs is there is a project called the Kubernetes Operator, which is in the open source. A bunch of people from the Ray community came together to write it. And Kubernetes Operator deploys 3 custom resources on Kubernetes clusters. So Ray cluster itself, then there is the Ray job to run ephemeral Ray clusters, and then there is ArrayServe to be able to create an inference endpoint for serving real-time machine learning. So, and all of this obviously works across any Kubernetes environment, pretty much. And it's pretty easy to get it up and running in a quick start way. So you can just, it's a standard Helm chart deployment. You add the Helm repo and then Helm install the Kubernetes operator that deploys the CRDs on the cluster. And then after that, you can use the Helm chart for the Ray cluster, or you can create a YAML file. Either way, that basically provisions that Ray cluster on top on top of Kubernetes. The nice thing about that is these RAID clusters can live in individual namespaces. These are namespaced scoped, so you can create multiple RAID clusters across multiple namespaces. So you have the isolation boundary for that cluster to be able to consume resources within a specific namespace, adhere to the resource quota limitations and limit ranges and any security and governance policies that you have within the confines of that namespace. So a very convenient way to run these on top of Kubernetes. Back to Christine.
Okay, thanks. So now, as a data scientist, you have the means to get yourself a namespace and get RAID cluster and Jupyter Notebook in that namespace. But remember that platform was set to run business applications, and business applications usually run on CPUs. But to run ML workloads, you actually can't use CPUs. You need GPUs for that. And that just reminds me about the time when I spilled coffee on my keyboard, and I had my computer, but I couldn't really use it. I went down to the IT department and asked them, hey, can I have a keyboard? And they said, well, we don't have any in stock right now, but you can go search online, find one that you like, come back, tell us, and we'll get it to you in about 2 weeks. So I went online and I searched for a keyboard, and there was an overwhelming number of 698 choices. And I don't know about you, but when I see that, my brain goes, well, maybe I should get a really nice one, to serve me for the long run. So I checked the really nice ones, but then I don't want to lose my job either. So maybe I should settle for something in the middle. And then still remember, even if I get one, I still need wait 2 weeks to actually get it. Wouldn't it be just nice if I could walk down the hall, swipe my badge, and get a keyboard of pre-curated number of choices that are safe for me, for the most part, and access my computer. So if you notice here, the pre-curated number of choices, well, sometimes I would actually need that really nice keyboard, but I don't need it for the whole entire month. I just might need it for an hour or two. So now I have to start adding features to this vending machine. Also, while I'm at it and adding features, maybe I should expand the medium-sized keyboards to have more options and choices there, and just pick one that's available, or one that fits the best. So what would that look like in terms of the platform? How many of you here are using Cluster Autoscaler? Okay, two people. Okay, so Cluster Autoscaler is how Kubernetes is. It's an open source project that you can add managed node groups, and it can scale those managed node groups. And it does speak CPU. You can also add managed node groups for GPUs to Cluster Autoscaler. However, what Cluster Autoscaler is not aware of is pricing. And here, remember that price tag? We need something that is very aware of the pricing. So to do that, we can replace Cluster Autoscaler with Carpenter. Carpenter is an AWS, it's a project that came from AWS. It is open source. It has been open source from the beginning. And it recently got donated to CNCF SIG autoscaling. So Carpenter, the differentiator factor here, why organizations choose Carpenter for running machine learning workloads is 2 things. First, Carpenter can bring up an instance in a matter of seconds versus a few minutes for Cluster Autoscaler. And as I mentioned, the other one is definitely price. Carpenter is aware of pricing, and I'll show you in a little bit how that works. Also, to make that cluster speak GPUs, you would need the NVIDIA device plugin, because the scheduler doesn't recognize the GPUs. So you install the NVIDIA device plugin, and it registers an nvidia.com/GPU type with the scheduler, so it starts recognizing the GPUs. All right, so we set up Carpenter, we give it some GPUs. If you are looking to move from cluster Autoscaler to Carpenter, we're not going to cover that here. There is this talk happening at KubeCon EU next week on Tuesday. If you're going, attend it. It's going to be a great one. If not, watch the recording after. It's going to be okay. So let's go back to our vending machine and see how we can make Carpenter provide these sizes for us. So before we talk about sizes, let's talk about why we separated them in these categories. Because you could tell me, like, well, right now I can give all the instances to Carpenter. I can just have one size, and Carpenter should figure out the best price, right? It's aware of the pricing, so it should figure out the best price. Well, the difference why we separated in medium, large, and extra large is because the NVIDIA type. So data scientists would use a different NVIDIA type to run different workloads. For example, you can run like data transformation experiments or on A10G. You can run inference on H100 and maybe fine-tune large language models on A100s. Okay, so we know now why we have 3 different categories here. So for Carpenter, we're going to create 3 node pools, and you don't have to read all that. I'll explain it, don't worry. I know the back of the room can't see this here. So we'll have a node pool for each of these categories. And for the category, for the medium, we have 3 instance sizes. So Carpenter will select the best price depending on what we ask it to do. The other categories, however, we have 1 instance only. But if you notice here on the last line, we have a spot and on-demand. And usually the spot price is better, but sometimes the spot price will spike above the on-demand price, and that's when Carpenter would know it will pick the cheaper one. So we set 3 node pools, but we actually don't apply this to our cluster. What we're going to do with these YAML files is we're going to put them in a Helm chart. And we're going to put like a little if-else statement here with Helm. The top line is like if experiment size is medium or large or extra large. And don't worry, it will all make sense in just a moment. Okay, so now if I'm that data scientist, that YAML file that I'll create my namespace with looks like this. And it has an experiment size. So if I give it an experiment size, my tooling under the hood will know that I need to, it will create for me a node pool of size medium. Okay, you with me so far? All right, so while we're talking here and we're building this platform, the company hired a few more data scientists, and now we have a team B of data scientists as well. And they decide that at the exact same time we're running our experiment, they will also run an experiment of size medium. So now, via the tooling, they'll have another node pool of the same size. So how would the Ray cluster in Team A's namespace know to schedule that experiment on the first one and Team B's on their node pool? Well, there is actually 3 ways you can do that with Carpenter. It's by matching the labels, by matching the annotations, or the good old taints and tolerations. So in this case, we're going to use taints and tolerations to do that, but you can use labels and annotations. So in this case, we put a taint on those, and we set the taint is experiment name, team-experiment, that's an arbitrary name that the team set. And then Ray cluster in the configuration will give it a toleration for that taint, and it will run the workload there. Okay. So now the screen is getting really crowded here, so we're going to send Team B on vacation for the time being. And just to reiterate, so now Team A gives this very nice snippet of YAML. I just want my experiment size. Here's the experiment name. and here's my team role, and it will create the namespace with the Carpenter node pool of the proper size. In this case, medium. So let's use now that setup to actually run, to see what happens when we run some workloads. Okay, so I can access the Jupyter notebook, and I will give it, in this case, I'll request 4 GPUs for my experiment. And let's take a look at those instances. 2 of those instances have 1 GPU each, and 12 extra large has 4 GPUs. So also, one thing to mention here, in the array configuration, I have set resources, I have set limits. And how I want to set those limits is that this pod that will come up, I want it to fit in the smallest size in my group, but I want to leave some room in there for the daemon sets and things like that. So I'll kind of push it to the max, almost to the maximum memory in CPU, but not to the max. So that's why these settings. So now if I run this notebook, Carpenter, because I requested 4 GPUs, has a choice to, like it has many options, but one option would be to bring me 4 instances for 2 extra larges and fit 1 pod each, that's 4 GPUs, or it will have a choice to bring a 12 extra large and to fit all 4 pods on that one. And it will do, again, that calculation based on pricing, spot, on demand, all the good things we talked about. So the great thing here is also that when we created the namespace and we put Jupyter Notebook and Ray cluster into that namespace, those actually run on CPUs. Only the workloads, when I provide an experiment of size, when I run a notebook, then it brings up the pods, it runs its job, and then the pods go down. And even though I still have my node pool there, Carpenter will take those instances down. So I will not be paying for those GPUs. It's just, as the job finishes, Carpenter takes down those pricey instances. All right. Okay, so let's go back to the vending machine, and now I have these, oh, sorry, I forgot to tell you one thing, the maximum replicas. If you set up Carpenter, so minimum is 0, of course, it can scale down to 0, but I should put some upper bound here so I don't do, guardrails. Good idea. In this case, 10. Okay, so let's go back to the vending machine now. So we have now all these nice features. We can use GPUs. We can bring up namespaces. It's going to select the proper cost-efficient way to do that. Well, that's great, but what if I need a USB drive? Can I get that? Well, let's go back now to the platform and see. I have this nice way of creating the namespace and Carpenter node pool. Let's see what it would take the current platform to create an S3 bucket. So first and foremost, that S3 bucket would need a few more resources than just an S3 bucket because we need Ray to be able to access it. And to set up access today, developers would just use Terraform. They would either open a ticket for the platform team, which would take another 2 weeks to turn around, or they would just go straight to Terraform. And let's see what that process would look like in Terraform. Well, they'll have to write something like this. And you don't have to read all that, but it is not straightforward. So some platform engineers have put all of these complexity in a module. And even if it's in a module, you still have to go and apply it to the account, wait for those resources to get created, grab the bucket name, which is straightforward, but then also get the role, which is not so straightforward if you're a developer or data scientist, pass that into your Git repo. Possibly you know the proper location and the proper value in your YAML file to pass it, and redeploy your application. So that process is a lot different than what we're trying to get as a vending machine, that nice YAML. If I'm a data scientist, I don't even want to know that this bucket exists. I just want to use this. Remember that this is my interface, and I kind of like it so far. So what if I install a controller to extend the Kubernetes API in order to be able to create AWS resources? Currently, we have two options for that. One is called ACK, which stands for AWS Controllers for Kubernetes, and the other one is Crossplane. So I can install a controller to extend my API. Actually, the platform engineer will install that controller. You don't have to worry about it. And with that controller, with the namespace creation, you can set everything up for that S3 bucket to come and the proper permission, so you don't have to worry about like getting an S3 bucket. It would just happen automatically and get connected to your RAID cluster. Great, so we can get an USB drive now from the vending machine. But we've done all this work so far. So how about we put a cherry on top of it? What that means is the data scientist now has to use a Python library called Boto3 to access that S3 bucket. And Boto3 is okay, but how it writes files and read files, it's not the best experience there. So we can make it a little nicer for developers, and we can actually mount that S3 bucket as a file system while we're at it. And we can do that with S3 mount point that came out November of last year at reInvent. They announced it. Okay, so now we have the vending machine, we have the cherry on top, and now we're actually going to show you how that works in practice.
This is a recorded demo, so I'm going to be pausing it if I need to explain something, or otherwise I'll keep it good. So just bear with me here. All right, where I'm starting from is a Kubernetes cluster. It's an EKS cluster, but it is Kubernetes. It's got some basic platform components already deployed on it. Right? So if you look at the list, right now it's Argo CD, which is going to be a way for me to pull down Git manifests and apply those Kubernetes manifests on my Kubernetes cluster. And there's a bunch of other daemon sets, but the one to notice is Carpenter, the NVIDIA device plugin, the S3 mount point, which Christina talked about, and the kuberay operator. So all of these are the building blocks of my data science platform. All right. It is, I think, a two-node cluster, so all of these components right now are running across two instances in the node group. Right. So now let's take a look at going back to my UI. Right now, Argo CD is running, but it's empty. There's nothing running on it, right? It's waiting for applications to be provisioned. It's actually monitoring this repo. This is my vending machine, right? This is the repo where I will be asking my internal team members, data scientists, to open a pull request with that YAML file that Christina showed. And they will open a pull request with that YAML. I, as a platform engineer, can approve and merge that pull request or decline it, hopefully approve it. The idea is that this is the only interface that data scientists have to learn. They just have to know how to open a pull request and ask for what they want, right? So, oh, look, we already have 2 data scientists asking for Jupyter Notebook and Ray clusters. So we're going to merge a pull request from team A They want to onboard themselves onto the platform. They give me an IAM ARN, which is the way they access AWS. Right? That's the role that was given to them by the cloud governance team or the cloud CCOE or whatever. They use that role to access AWS accounts, so they give me that role. And they tell me, my experiment size is a medium. I'm not doing much, but I still need an environment to do. Cool, let's merge that pull request. And now, when that request gets merged, Argo CD notices that there is a new environment that needs to be provisioned for this particular team. So in a few seconds, Argo CD will reconcile and start deploying that team's resources. And here we see Argo CD kind of creating that application. This is the app of apps, so to speak. So under this app, we have multiple Helm charts being deployed onto the cluster. And we'll get into that a little bit later, but you can see a bunch of resources are being provisioned. And all of those resources map to what Christina showed earlier with the diagram. It's the Jupyter Hub notebook, the array cluster, the S3 bucket, the IAM roles that need to be provisioned to access that S3 bucket. All of that complexity is completely abstracted away from the data centers. They don't need to know all this is happening behind the scenes. Right? They just open a pull request and we merge it for them. Cool. So now that these resources have been provisioned, remember, there's Carpenter running on this node, and we need to provision additional EC2 instances to be able to accommodate all those incoming pods. So Carpenter has noticed that these pods need to be provisioned. It goes ahead and provisions an EC2 instance type, and then once those instances are ready, we can see that in the team A's namespace, they will be scheduled on those newly provisioned instances. So all of this wiring is kind of what this vending machine is doing, right? So now that we have the environment up and running, we can now give the URL for Jupyter Hub to the data scientists, and they can log into their notebook instance. They didn't know what just happened for all of this to basically, just to give you a notebook, right? So they spin up the notebook, and we have some pre-curated notebook containers that they can use. These are approved notebook containers from IT and AppSec and whatever security governance controls you have. They use that notebook to be able to run their experiments. For my example, I'm running a simple data transformation job within the notebook. If you are a data scientist or have worked with notebooks before, this is probably going to look super trivial to you. For me, it was a lot of work to actually get it to work, but I'm pretty proud of it. Pip install a bunch of dependencies that I'm going to need to be able to run this experiment. After that, I'm going to be just creating some staging area for my data set to land, right? So I'm going to be pulling in a sample data set from the internet and from the public domain to run my experiment. And remember, we have S3 mount points now. So this mount point is being used as a file system within this notebook. So whenever I'm pulling down a large data set, it's going straight to my S3 bucket. I don't have to worry about AWS S3 CP star.cv to a bucket URL, right? I'm writing it to my local file system. I'm using PyArrow to read that irs.csv data set. It's a very commonly used data set. It has data about flowers, the different lengths and widths. But what I want to do in my transformation is to calculate the area of those flowers or something like that. So I have the length and the width. I do a product of those, and that's the area. I want to add that area as a field inside that data set, the newly created transform data set. So this is what's happening in my transformation script. But I want to run this across a set of, in a distributed way using array cluster. I want to create a batch of this, chunk up the data, and have these array workers simultaneously work on these chunks of data. And then in my notebook, I'll gather all that data back and concatenate all of that into my transform data set. So that's the array script that basically does that job. I submit the job to the array cluster. The nice thing about Ray is that any dependencies that you need during the runtime of that script can be dynamically installed onto the Ray cluster using, just pass in an array of your pip dependencies, and Ray will dynamically just install those as it spins up. I've also copied my transformation, the Python script, to an S3 bucket, which gets mounted inside the Ray cluster as well. And remember, I'm just writing everything locally. I don't know that it's landing in an S3 bucket. It's just Ray that's just picking it up because it's the same bucket that's mounted inside the Ray cluster as well. I submit the job's going on, and now I'm just monitoring the progress of the job. With the simple loop, I can just keep pulling what's going on. It also forwards me the logs from like the jobs that are running, so if there's something going on that I need to take a look at. I have the logs in the notebook, but if I want to dive deeper, Ray dashboard is always handy. So I can open up the Ray dashboard within the browser, and if I want to deep dive into like if something went wrong, or if some logs are not showing up in the notebook, I can always do that. Remember Carpenter? Ray worker needs a node, an EC2 instance, to be able to run on. Carpenter has noticed that Ray worker needs to be provisioned. It needs an EC2 instance. It's a medium-sized experiment, which means it's going to run on CPUs. And so it's figured out that I can do this on a C6 X large instance, and that's what it thinks is their best choice at the moment. So it goes ahead and provisions that, and the Ray worker, the Ray autoscaler brings up the worker pod. The worker pod gets scheduled on that instance. It's up and running, and it's going to go ahead and finish that transformation job across those Ray workers that got provisioned. So the job succeeded. I can check the logs if I want to. If not, I can go back to my notebook instance, and I can test whether the job, the transformation actually happened the way I wanted it to happen, or do I need to run it again? So I need to, again, like concatenate all of those chunks that were performed by those individual workers into a single CSV file. And let's check. So yeah, it works. So the pedal area centimeter squares field was added to my newly transformed data set. So now that I'm able to, this basically is again, to call out that the newly transformed data set is also landing inside the S3 bucket as well. But I'm writing it locally on a file system. Just to prove that I'm not lying, it's inside the S3 bucket. So you can see the raw data set and the transformed data set and all the partitions. Everything is inside the S3 bucket. So now if there are other jobs that need to, if there's a glue job that needs to take a look at it, or if there's something else, some other team that needs to access that data, it's already there. Right? We have one more team that we need to land onto the platform. And this time, this team B wants to do a batch inference using GPUs. So they've asked for GPU medium. Again, same config.yaml with the principal ARN and the size of the experiment. Merge that pull request. Now team B resources are going to get provisioned onto the cluster. Again, Argo CD controller reconciling, notices team B has landed, and starts provisioning the resources that team B needs inside team B's resources. Team A's resources are still there on the cluster, but they're left untouched. Team A is off to the races. Team B is spinning up. Same deal. It's the same cycle repeating itself, right? So we have pods landing into the cluster. Carpenter noticing that these pods need EC2 instances. Let me go figure out the best instance that I can get at this point in time, spot or on demand. And it's going to, once the instance is provisioned, Kubernetes scheduler provisions those pods onto the newly created instance for team B. This time, Carpenter has chosen to do an M5 AX large because that's what it thinks is going to be the best choice. Remember the taints that we were discussing earlier? This is the team B's taint, so no other workload that has that doesn't have the toleration for this taint can land inside inside this node. Team B's Jupyter notebook, RAID cluster spinning up. It's the exact copy of Team A, but a more larger size, because they have asked for a larger size. And they're going to be charged for it. Looking inside the RAID cluster, just a sidebar here to see what RAID cluster looks like. There's a head group node and a worker pod. The head pod really doesn't do much other than maintaining the cluster membership and directing like the jobs themselves. It's the workers that do all the work. So we have, in this case, we have configured a max of 10 replicas, min of 0, so it has the ability to scale down to 0. If you need to keep a worker alive, just bump up the min replicas, desired replicas to whatever size you need. And we have resource limits defined per worker. So every worker gets a max of 7 CPUs, 30 gig of memory, and 1 GPU each. So if the data scientists need more than that, then they need to ask for a larger experiment size that they can work with. All right? And now the array autoscaler comes up. The data scientists can, again, from Team B, can go into the Jupyter notebook. This time it's Christina. Notebook spins up. One thing to remember is we asked for a GPU instance types, and we're going to see like how that's being handled here. I'm using another notebook here for a prototype. This time, similar to the previous case, I need to install a bunch of dependencies. So same deal, like it's the array package, creating a staging area for my data set to land in. Again, it's the S3 file system. That's getting mounted inside the notebook. Maybe I can skip a little ahead. All right. So in this case, the array job that gets run is an image classifying job. So we're using an ML model that can classify a data set of images and add the score and the label on what it thinks is inside those images. But this job, according to this data scientist, according to Christina, needs at least 4 workers with a GPU each, which means there needs a total of 4 GPUs for it to run efficiently. After the predictions are being made, the batch predictions are done, I want to take a sample of those and just experiment with them inside my notebook, right? So this is what's happening. Basically take a sample, create a data frame out of it, stick that pandas data frame inside an S3 bucket, which I can then load up inside my notebook again. Submit the job. My code is in an S3 bucket again, which gets picked up by the array cluster, and dependencies as well for the script to run. I submit the job runs. I'll skip ahead. It's running. Now that the job has finished, I can test whether it's successful or not. So I can install pandas locally in my notebook and check on it. Remember we said Carpenter takes those instances away? My experiment is done. I'm done with testing my data. And so I don't need those GPUs anymore. I don't need to manually shut them down. Carpenter knows there is no more workers running on those GPUs, and it's going to spin down those instances. It's similar to cluster autoscaler, but it's a little bit more quicker, and it's more smarter about how it's doing things. And with that, again, to prove that I wasn't lying, there's an S3 bucket with Team B, and all of that data is in there. All right. I'll hand it back to Christina while you watch that. Thank you.
Yay, the demo worked.
Well, it was recorded. I cheated.
It's okay. That was an awesome demo. And if you notice, the first experiment ran in CPUs to be even more cost effective, which we didn't cover in the slides. And that's what the risk is when your co-speaker really likes to play with that stuff. So I think the first demo, there was a smaller model that would fit CPUs, so we added even like a smaller subset. Okay, let's get back to that. So now we have our vending machine. We know how it works. We have all the bells and whistles and the cherry on top here. And now if I'm that data scientist, and if you ask me, that PhD, totally worth it. All right, so if you want to find out more, we have data on EKS that has a lot of examples for Ray, Spark, and more. Go check it out. Trinium. And thank you so much.
There we go. All right. I'm going to steal this and run it for questions so we can get it on stream. Anyone have questions? Any comments?
My experience with Jupyter Hub and Python modules has been pretty time-consuming getting all the dependencies. And people I work with have resorted to VENV for compartmentalizing all the necessary modules they need. How does this deal with a dependency stream that might take 10 or 15 minutes or may even be impossible to resolve when you spin those up?
What was the tool you said?
VENV, virtual environments. Command line tool.
Okay, I'm not familiar with that. I don't have a good answer for you. I just say that most of the customers that we work with are in the camp of Jupyter Hub or Jupyter Notebooks. So your question is, how do you handle Python dependencies?
How does the product handle Python dependencies?
So this is not a product. We are suggesting a pattern that customers or any platform engineers can use to deploy data science related components on top of Kubernetes to make it easier for data scientists to be able to do their jobs without dealing with the complexities of Kubernetes or a cloud provider. If there is some other tool that deals better with it, this pattern will work hopefully with that tool as well. This is not about handling software dependencies at the data science level. Like, we're not dealing with that issue at
all. I'm not too familiar with the S3 mounts, but I'm wondering how you handle bucket policies when, let's say, somebody wants to write data to a prefix they have no business writing data to. How do you handle, I guess, just permissioning when you mount that data locally?
So the question was, with that S3 bucket we mounted, regardless of the S3 mount point, with or without, how do we handle permissions to that bucket in this case? Because in the example we showed, that data scientist from the namespace would have access to everything in that bucket because it's a bucket per experiment. So we're spinning a new bucket per experiment. It could be set up to where you have a prefix per experiment. That would work too for a single bucket. In this case, we use the controller, either ACK or crossplane, that wires up the IRSA, which stands for IAM role for service account, or it can also do the new way of doing permissions, which is pod identity, in order to access the bucket or a prefix in the bucket. So the controller wouldn't just create a bucket. It would create the role, the policy, and it can also link, like it can take the bucket and put the bucket into the bucket ARN. And like if you design your controller API to do a prefix, you can even pass it a prefix. And then let me just go back to that slide real quick here. It's going to make more sense. Let's see. All right. There we go. So the controller will set this up for you. So it will set all the permissioning. It's going to annotate the service account with the proper annotation, so it has access to the role. That will then assume the policy, and then we'll have access to the S3 bucket.
But your question is that you want them to have only some access to S3, right? Like here's, yeah, all of the teams are going to use the same bucket or something, and they all get their own prefix under that.
Yeah, that makes me feel safer.
Yes.
Yeah, so if you want that, you can set up the controller. So the controller has options, and depending on which controller you use, like for example, let's go with the example of Crossplane. Crossplane, you have the, like, when you install Crossplane, it comes with the S3 API. But then it has a construct called compositions and XRDs, with which you can build on top of that S3 API. You can build another API on top of your API. Does that make sense? And then your API can be specific. You can say, I can only pass in a role, and I can hard code my bucket name for this cluster, and I can pass it a prefix per experiment. And then it's going to come here, and it's going to set up your policy only for that bucket, only for that prefix.
Do you know how the new S3 volume mounts work with principals? Because at some level, my principal won't let me write. If I say I don't get to write to this prefix, and then I mount the file system with the S3 file system mount, does it show up for me? Is it just a read-only file system? I haven't played with the file system mount.
Yeah, if your principal does not have access to the S3 bucket, then you're not going to get it.
I can still mount the file system. I just won't be able to write to it, or maybe not even see it. And so that might be the best way, is just in your principal, when you mount that file system, just say, hey, this principal can't map to this prefix.
Yeah. Yeah. Does that answer your question? Yes. Okay.
Any other questions? All right, and I'm sure you'll both be around at least for a little while. I know you have to get out to Paris sometime soon.
We'll be around for the break.
But yeah, thank you so much.
Thank you.
Thank you.